Okay, all right, finally. Okay, thank you all for being here. So yeah, I was just mentioning, this is the first time I'm running this HPC Fundamentals course. And so you're gonna have a couple opportunities to give some feedback and help me improve it for the future. But we'll do what we can today, and hopefully by the end of the session, you'll feel a little bit more sort of ready to start using our HPC resource here at NERSC. I'm gonna talk about what that is, what that's called. And then even if you're a little confused by the end of it, some of the resources that we go through today might help you kind of do some self-study afterwards. And I'll talk about a couple other training events that we have coming up as well. Okay, so as a reminder, this session is going to be very interactive. So there'll be times there's sort of like hands-on exercises. I'm gonna introduce some of them. The point is not for it to be very lecture style. There's going to be a little bit of lecture here and there, just obviously to kind of help you understand what the activities are and what we're doing. But for the most part, it's going to be a lot of like, you're welcome to just explore, talk to your peers, talk to me, talk to Acton here. I'm going to introduce in a moment. But again, we're all here to learn, including me, because this is the first time I've ever run this course. So just as a reminder to be respectful to each other. If someone has a question, just help them out or say, hey, I don't know, ask the teacher. Just make sure everyone's learning at all times and having a good time. So here are goals for today. This is what ideally by the end of the session you'll be able to do. So hopefully you'll be able to use terminal commands to navigate and organize files. You'll be able to copy a project directory into your workspace on NERSC. You'll be able to understand a few things about the shared resource that we're all going to be using today, which is called Perlmutter. We're going to be submitting a simple batch job using Slurm. Again, if you don't understand what batch or job or Slurm is, that's okay. You will hopefully know what those things are by the end of this session. We're going to do something called an interactive allocation. And so that's also something, if you don't understand what that is, you will. We're going to read some Slurm output files and do a little bit of basic troubleshooting. And then hopefully at the end, and I'm not sure, it'll depend on how we do, we might be able to try a little bit of scaling and getting something to run a little bit faster on our system. Okay, so ref agenda, it's already 9:10, so we'll kind of scooch through here. The first part we're going to spend probably the most on, because it's kind of the part that's important to be able to do in order to do all the rest of the stuff, which is understand what a terminal is and use some bash to navigate a terminal. We'll take a little break so everyone can stretch. And then we'll do some sort of running jobs 101 and maybe running faster jobs, which I call 102. And then we'll have what's called, post-survey. We're gonna have to do a pre-survey in a minute here. And then we'll have hopefully have a little bit of time for people to just work and ask questions or get through some exercises or pick my brain about anything. Okay. Okay. All right, so I just want to introduce myself, just so you can know a little bit about who I am and why I'm up here talking to you. So my background is actually in physics. So I completed my undergraduate degree in physics from Cornell University in 2015. And then I went on to do my PhD in physics as well. So I'm actually an accelerator physicist by training. And I did my PhD over at University of Chicago, but I did spend some time down at SLAC National Lab. So I worked over at Stanford for a while. Well, it's not at Stanford, it's like near Stanford. And that's actually where I did sort of half of my PhD research. And while I was down at SLAC is when I started using NERSC systems. And at that time, our system was called Cori. So I started using NERSC as a graduate student using Cori for my simulations. And that's sort of how I got introduced to NERSC, and that's how I got bamboozled into coming here. My current boss, she and I chatted, and she sort of convinced me to apply for a postdoc here, which we do offer postdocs. They're not like traditional scientific postdocs, so the aim is not necessarily to be like pushing out a bunch of publications, but it's really good sort of training for if you happen to want to go into high performance computing. And so when I came here as a postdoc, I was working with scientists up at the Advanced Light Source, helping them with so they are collecting all kinds of data up there, but the beam line I was working with is a tomographic detector, and I was helping them figure out a way to kind of like submit jobs to our system really quickly. And then I got hired here as staff in 2023. I will say I was not comfortable with computing as a physicist. I spent a lot of time doing Mathematica, which if you've ever used Mathematica is like very analytic, like you're typing in equations and it's sort of like integrating them for you, things like that. So running jobs and using a terminal was like something I had done and knew how to do, but it wasn't something I felt really comfortable with. So building a computer for myself was something that was never on my agenda. But once I started working at NERSC, I was like, this probably isn't that hard. And I put together my own PC, which I know a lot of people do, but for me, that was like a big landmark. Because for me, computers were like just a thing you bought at the store and then you use it for the internet or whatever, like that was it. So that was kind of a full milestone for me. But besides being a physicist and a computer person, I raise guide dogs for the blind. So this slide is meant to let you know that I'm an entire person as well. We're not just all here sitting behind our computers all the time. I raise guide dogs for the blind as a volunteer. So these are my 4th and 5th puppy. So I love dogs and I'm happy to talk about them all the time. If I'm not with my dogs, I'm probably riding my motorcycle. This is an adventure bike, so it can go off-road. So I'm on the logging trails. I live in Oregon. And if I'm not doing any of those things, I'm probably cooking. So I got my sort of spread of hobbies here. And I love talking about all of these things. So you're welcome to ask me about any of them. Okay, so we have several other helpers here today. Some of them are not here immediately, but they may come and go. You've seen Helen probably if you're in the Zoom. Helen is here. I'm not sure if any of our other helpers are here yet, but they may be. Let's look, are any of them here? I don't want to scroll through all the way, but if you're here, you can say hi or wave. But they may be coming and going. So, Charles, was that you? No. Okay.
Hi and wave.
Okay, great. Helen is waving. And then in the room we have Afton. Afton, would you like to say something about yourself?
Yeah, I'm one of those NERSC postdocs that Olivia was talking about. I am a postdoc in the Programming Environments and Models group, and I've been at NERSC since March of last year. And yeah, just here to.
Yes, Afton is my lifesaver TA, if you will. So if you have some questions, if you're running into things that I'm kind of busy, then hopefully Afton will be able to come over and help you. The other thing that's really important today is if you have questions, please do feel free to, if you're in person, you can raise your hand. Even if you're online, you can raise your hand. I may or may not be able to see it. We also have this thing called the Q&A doc. So Helen has probably been spamming the chat with this Q&A doc link. I would encourage everyone to get in there because that's what includes a lot of the other stuff we need for today. And then, yeah, you can also ask Afton if you need some help. Online, if one of our helpers is online and you need like extra help, we can make a little breakout room and you could even go and like sit in the kitchen or something and work with them more one-on-one if you need to. The most important thing is that you should not assume that your question is stupid or, whatever. Don't suffer in silence. The point is of this course is to get you ready for whatever you're trying to do this summer. And you will realize that summer, if you happen to be here as a summer intern, if you're not, that's different. But if you happen to be here as a summer intern, it goes by very quick. So if you're stuck on trying to submit a batch job or do some of these sort of more basic things that are kind of underlying everything else you're trying to achieve on top, it'll frustrate you and it'll slow you down. So that's the goal of today, is to make sure that there's no roadblocks to you using our system in some of the kind of basic ways. Okay? So any questions at the current time? Okay. Some other trainings that we have coming up that will be useful. So this training that's coming up this coming Monday and Tuesday, and I will be here in person doing those as well with other people, not just me. And that is the new user training is sort of aimed at like anyone who's a new user, and I'll talk about this in a minute. But we have thousands and thousands of people who work on our system. And those new users, they might be just new to our system or they might be new to HPC. So the new user training is meant for like anyone. So it can be a little bit higher level. It kind of assumes some of the basic knowledge that we're going to talk about today. So ideally, this will help you get ready for that training. We have what's called the supercomputing crash course. This is like the real training on parallel computing. So like today, I'm gonna talk about one or two things very briefly. I'm actually really not an expert in parallel computing. So if you have questions about that kind of stuff, I highly recommend attending that training, and the registration for that should be open. We're also going to have office hours that are going to start in a couple Fridays. And so those will be held every other week. And the details for that, probably maybe in the Q&A, or you can always go to the NERSC calendar. So our main website calendar has all of our events listed in there. And if for some reason you can't find what you're looking for, you now have my email address. You should feel more than welcome to email me. There's no problem with you.
Question, will be in this building,
Which one?
the office hall?
I think office hours are fully online.
Okay.
They're completely remote. Yeah. Any other questions? Okay. All right, so now we're gonna take a quick pause and we're gonna do the pre-survey. So if everyone, so is everyone in the Zoom? Yes. So in the Zoom, you should have seen this link to this Q&A doc, and I can pull it up here. So this is what this Q&A doc looks like. And you're gonna go to this link right here. It's the bottom of the first page, and it's called pre-survey. And we're gonna take about 5 minutes for everybody to go and do this pre-survey.
How do I access this link?
So if you go in the Zoom chat, there's a Q&A doc. Oh shoot, is it not open to everybody to use?
Looks like mine got denied.
It got denied. Okay, everyone hold on. Let me change the permissions. All right, let's fix this. Responder.
Oh, that's not. Yeah, there.
Thank you.
Okay, all right, everyone try one more time and see if the permissions have been fixed.
Yeah, it looks like it's working for me.
Permission is okay for me.
Okay, great. Yeah, Helen, I think it was probably good for you because you have permission for everything in that.
Right, I'm a staff.
Okay. I think Google has locked down permission so much that now you have to change it.
Yeah.
So, okay, sorry about that. Everyone should have access now, so try again. Just take 5 minutes. Don't spend too much time on it.
There's a question in chat to share the link again.
Okay, so if you, yeah, so can someone put the Q&A doc link in there and then you can find, I can put this link in there as well, but you should have access to the Q&A doc.
May I say something? I am from HPE and I have access to Paramotor. So if anybody wants to visit it, let me know.
So we're gonna do a tour on Monday. So if you want to go on a tour, you can do that on Monday. I'm not sure, I mean,
No, I can host a tour today.
okay, I think usually the admins like to know ahead of time, but
It's permitted, but I have only permission to take 9 people with me 10 at a time. So,
okay, are we done with the pre-survey? Okay, all right, let's continue on. Okay, so let's get into it now. So I'm gonna give you a quick intro to NERSC, just so you have an understanding of, you know, what we are, why we're here, what's going on. Oops, I didn't share my screen again. Okay. All right, so hopefully you know that NERSC is part of the Department of Energy Office of Science, which is one of the largest funders of physical science in the US. So there's all kinds of different science that's done here, and the key point being here that everything that's being run on our system is meant to be open science. So we don't do any secret stuff here. Everything has to be publishable. I don't think that means that you will publish it or something, but it technically has to be open so that you could publish it. So there's a bunch of beautiful pictures of the science that people have done. I don't know what any of these things are though. Just so you know, you are in this room, there's about 20 of you. There are 12,000 users of our system. If you log in later today and you type in the word top, you'll be able to see on any given login node how many people are on that node. And it's usually, I was doing it the other day and there was like 800, 600. So, you know, there's like huge amounts of people on the system at a given time, which is why we're going to talk briefly about what it means to be like a good citizen on a shared system, because it's not your system. There's tons and tons of other people and everyone has to be able to do their computation, which is also the reason that we have this thing called a workload manager. We can't just have everyone sort of like doing their own thing because we have kind of limited resources. So or finite resources, I should say. But an interesting thing here is you'll see the sort of plurality are students. So we've got graduate students, undergraduate students. So, you know, if you are a student, you are in the majority in that way. But the point is, lots of people who are coming here every year who are brand new to HPC. And so that's part of the reason we do some of these things. You'll see that there's every single state represented, tons of different countries, just a lot of different people here at NERSC using our systems. Okay, so if you haven't seen our system, this is what it looks like. These are, one of them is a cartoon, the other one is a picture. So all these different racks, I'm going to talk really fast about what these are, but you can see here, there's all these different racks, and within those racks, I'm going to show you the anatomy in a minute. That's where your computation is actually taking place, okay? So we have 2 types of nodes on our system. We have GPU nodes and CPU nodes. So a node is kind of like a unit. You know, sometimes you could be like, it's like your computer or something, right? Like it's your little laptop, right? You can use multiple of them. They're all connected to each other, which is different than a laptop. But there's sort of 2 different types here. One of them has 4 GPUs and 1 CPU, and the other one has 2 CPUs. We are going to be using the CPU nodes today. We're not going to be doing anything on GPUs today. The way that these nodes are put together, you take them, you kind of put them all onto this thing called a blade. So on the CPU nodes, there's 4 of them. Blades. There's 4 nodes. GPU, there's 2, and then you kind of stack them sideways into sort of like a bookshelf situation, and then they get shoved into a rack. So that's what you know. In case you've ever looked at this and been like, "What is in this cabinet?" Right? It's basically a little compute on these things called blades. You shove all the blades into the rack, and then the rack is, there's like 30 of them, something like that, okay? Each rack, it says here, has, oh, you can't see it for some reason, times thing, and I don't know how to get rid of that. Maybe you can see it here. There's 64 blades. Okay, so how do we talk to this thing? How do we work on this thing? Find out. Okay, so I have some videos because Videos are more fun than me talking. And I did test the sound, but we're gonna see how it works. Naturally, it's not gonna work. If we're testing it, it doesn't work. Yeah. Oh, I know what the problem is. Oh, are you kidding me, Adam? The sound on the other thing is turned up all the way, so, all right, let's hope I don't.
Developers. Let's go back over 60 years ago.
Mac Studio.
MacBook Air.
The future.
A card file, a notepad, a clock.
The third industry milestone product, Macintosh.
Has the computer made your life easier?
Made it more fun.
Revolution in technology.
Required in working out the solution.
New uses are found for computers.
The modern terminal we see today is heavily inspired by teletype computers. These computers were made to allow people to send and receive text-based commands using a keyboard and printed output. In the 1960s, a lot of places that were able to afford these types of computing were structured with a large mainframe computer that had a physical attachment to a teletype interface. Here's how this technology worked. Every time you would click a character, it would transmit that over the wire. The kernel of the mainframe computer would receive this input and then decode it. This decoded text is sent to something called the TTY driver, which was responsible for sending the user's decoded input to programs and collecting output. This would then be sent back to the user for them to see. What made this really incredible was something called the line discipline. This would buffer the characters in memory and wouldn't send to the TTY driver until the enter button was pressed. Other optimizations were made along the way, like being able to edit something if you made a mistake, or keyboard shortcuts. You can see how our modern-day terminals are starting to look a little bit like the teletype. Now, 1970 unveiled incredible technology. The VT05 all the way to the VT100 introduced an all-in-one video terminal that can support ANSI escape codes, colors, and sounds. This machine was revolutionary, but still based on the same premise: input and output. Technology advanced, computers were no longer just machines to talk to larger machines. Operating systems were now developed and they were almost everywhere.
So I thought this was pretty interesting. It's nice to know that a terminal is kind of like very close to the way that we talk to like computers when they first sort of became available to us. But obviously now and in the future we might look back and see like, wow, this was really archaic. But compared to what people had to do before, we have a lot of freedom and accessibility features. And we're going to watch just another short little video to actually explain some of these basics.
When I first started working with the terminal, I did the thing. I saw a senior developer post some nuanced take on Twitter about something I didn't understand, and I tweeted him asking how he got his terminal to look like that. He was kind enough to point me in the right direction, and now I frequently field the same questions from beginner devs. Text-based interactions can be confusing and intimidating. Not only is there a lot of terminology to learn, but it seems everyone just knows this stuff. Perhaps you felt dumb asking or just didn't have anybody to ask. In this video, we'll go over 4 key terms connected to the terminal. And if you stick around to the end, I'll even help you get started customizing your experience so you don't have to ask on Twitter. Alright, first up is the term CLI, or Command Line Interface. This simply means interacting with your computer through text-based commands. So instead of clicking around menus or toggling switches, you enter text commands. Now, why would you want to do this? Well, let me suggest 3 good reasons: additional insight, power, and speed. Text commands often return helpful info. Typing PS, for example, gives you info about all the active processes on your system. Or the top CLI command provides a real-time dynamic view of all processes, including CPU and memory usage. Text-based commands also provide incredible power. Not only can you run commands as an administrator when needed, but you can also do advanced searching and filtering of text files, transfer data to or from a server, securely and remotely access servers, and much more. Finally, once you learn key commands, the CLI is often much quicker than alternatives. As a simple example, you can create a directory and fill it with an index.html, index.css, and index.js file in 2 commands. So, what is the CLI? Well, it's a text-based way of interacting with a computer. Oftentimes, services provide CLIs, like Netlify, so that instead of clicking through menus online to add environmental variables, you can set secure variables with a text command. Now, where do you type this kind of text command? That's our second term, the terminal. To simplify things a bit, the terminal is the window, the GUI, or the program that provides an interface for typing commands, whether you're on your computer or on a server. Windows, macOS, and Linux distributions include default terminal applications, but many developers prefer more custom options. There are lots of options like iTerm, Windows Terminal, Hyper, Warp, Alacrity, and more. These applications often provide better performance, additional features like split panes or customizable themes, or cross-platform compatibility, so you have the same experience everywhere. Warp, for instance, includes autocomplete, mouse interaction, built-in workflows, AI features, and much more beyond standard terminals. Now, most terminals let you customize the look and feel of the application by choosing your fonts, text colors, and more. So, CLI means text commands, and the terminal is where you type those commands. But what interprets your commands? Well, that's our third term, the shell. The shell is the software that runs in your terminal. It takes your commands and then interprets and executes them. Most terminals can run a variety of shells. Some examples of popular shells are Bash, ZSH, and Fish. Now, Bash was the longtime default on macOS and Linux distributions, and it's still used for most servers. On both macOS and Linux, however, it's been replaced by ZSH as the default, which is generally compatible with Bash but offers additional features like built-in tab autocomplete, syntax highlighting, and more. Basically, it's known for being more user-friendly. Fish, or Friendly Interactive Shell, has many of those same user-friendly advantages, but isn't always backwards compatible with Bash, which can make it difficult for some situations. On Windows, you have Command Prompt and PowerShell as 2 examples. And WSL, which stands for Windows Subsystem for Linux, essentially gives you a Unix environment in your Windows terminal application so you can run Unix shells like Bash or ZSH. So as you type text commands, the CLI, you type them into your terminal application, and your shell interprets and runs those commands. Now, which shell should you use? In short, it depends on your needs, but generally speaking, use whatever comes pre-installed on your system. One exception would be if you're a Windows user who's planning on interacting with Unix-based systems or commands. In that case, you should look into installing WSL so you can interact with those systems from your terminal application, as Windows is not Unix-based. Fourthly, let's circle back to the start. How do you get all those cool symbols in your terminal? Well, that's our fourth and final term, the prompt. It's provided by your shell and displayed in your terminal, and it's the input field where you type your text commands. While your terminal application can be customized, the input field where you type commands is controlled by your prompt. You can customize your prompt for your needs, setting its styling or contextual details, get info, and more. For example, my prompt shows my current working directory and get information. Different shells offer different built-in prompts.
Okay, so that's where I wanted to pause that because it's a good place for us to transition into actually getting on the system and kind of trying all the things that we just saw in the video in real life, okay? So I'm gonna transition over. So how many of you practiced SSHing and logging in to the system? How many of you are able to log in successfully? Yes? Yes? Okay, all right, well, we're gonna very brief, so there's 2 options here, and I don't like to use a terminal. I like to go and use our Jupyter interface, which has a terminal in it. So I'm gonna do that, but everything I do in there in the terminal is exactly the same as you would do in any other terminal, okay? If you haven't logged in, I did send out some resources, but I think, let me double check here. Is it in the Q&A doc? Oh. There should be a resource here to the beginner guide. I'll put that in here now. I put it right at the end of the resources. So that is going to show you how to log in. You did need to set up your MFA before you got here, so your multi-factor authentication. So if you haven't done that, take some time to do that, but it was in the email to set that up beforehand. Okay, so that's okay. Take the time to do that now then. Okay. You have a
I'm
question?
sure I have the access to the one we want to, but I have access to
What you would want to what, sorry?
the login. I have access to the Permuter manager and I have MFA and keys for everything. I don't know if it's done. Yes,
I don't know.
okay, so I may be
So-
lost.
Sorry about that. Maybe you can try using your account, just like try SSHing into Perlmutter directly.
Well, and where do we land in Promoter Manager?
You're gonna land on a login node.
To use and I don't know.
I can go to a login node from the back.
Yeah, I think I'm.
All right, so I'm gonna show you. Okay, so let me share my screen. Okay, so I have logged in here in Jupyter. You can also try logging in on, okay, great, on a terminal. So here I'm showing my terminal screen. I've logged in, log in using SSH. If you saw in the beginner guide, there's a nice little video that shows you how to do that. And then I entered my password and one-time password, and that lands me on our system. So this is what it looks like in a terminal. So let's see if this signed out. Nope, I'm still here. Okay, so I'm still on, this is Perlmutter right here. And you can see in that prompt, it shows my username, it shows that I'm on Perlmutter, and it actually shows that I'm on a login node. Okay.
Can you show the command?
SSH, let's see. Oh, no, it's not gonna be in here, because it's.
SSH perlmutter.nersc.
Yeah, so let me type it in another one here. Okay, so it's SSH. Then it's gonna be your username, so whatever your username is, your name. At Perlmutter. Delay. Oops, oh. At perlmutter.nurse.gov. And all of this is in our documentation, in that beginner's guide. So if you go in the Q&A, there's that beginner's guide. You can click on and that has all the commands. You can just copy and paste it, but you still have to change out your username. When I press enter, I'm not gonna press enter, but if I press enter, it would ask me for my password and my one-time password. So you should have set up your multi-factor authentication already. Did people have a chance to do that? Yes? Okay. If you didn't, you still can. It shouldn't take more than 2 or 3 minutes, max, not even. So if you go into the documentation, like I said, that beginner's guide, it shows you the link to go into Iris and set up your MFA. Okay?
So I've already logged in
Yeah.
the terminal. Do you want me to log out? I want to go to Jupyter.
You can do this whole thing in the terminal if you want. I just sort of like the interface of Jupyter, but I'm gonna be doing the exact same thing. There's no difference. So if you want to use the terminal, go for it. Like your whatever terminal program you have, if you have a fancy one. I'm using this terminal that I have here is literally just the basic one, the pre-installed one. Nothing fancy. I'm not even going to be using any of the Jupyter features. Maybe if I decide I want to show you something in particular. Yeah.
So does it require us to actually have a NERSC account?
Yes. Yes. So if you were one of those people that weren't able to get your training account by time, you're going to just be able to watch this part. You're welcome to watch another person near you, watch what I'm doing. I'm going to do everything and I'm going to explain everything. So you'll have to wait till you have your account and then you can do this. Yeah, so the training accounts and getting a NERSC account in general can take a little bit of time. And because the summer program started Tuesday, I think, right? A lot of you, if you're part of the summer program, started Tuesday, you may not have had time to get your account already.
Yeah, I submitted my request yesterday, so probably I haven't got it
Yeah,
yet.
so it could take up to next week, yeah. But I'm gonna show you what I'm doing here, and if you want to pair up with another person around who is doing it, you're, assuming they're okay with that, which hopefully they are. Is anyone okay with that? Specifically, I see here, yeah, go for it, yeah. Find someone. Mhm.
Sorry, I was just wondering. So I logged into that part, but there's just a whole bunch. It's a notebook right now, is where I'm at. How do I get into the terminal?
You're in a notebook.
Yeah, it sent me a notebook. It says like NERSC Python, Agentic AI Bootcamp, all that. But I have the same terminal that you're in, like in general.
You're in Jupiter?
I'm in Jupiter. Yeah.
So if I go to Jupiter, so did you get to this part right here?
Yeah, I did login node. Yep.
Login node, okay. And then, so if there's a notebook that happens to be open, you can just close it. And then if you want to launch a terminal, you can press this launcher, this little plus button here.
Mm-hmm.
Scroll down, and then there's a terminal right here.
Oh, actually, okay, scroll down and find the terminal. Thank you. That's what I was looking for.
Exactly. Yep. So for anyone who missed it, so if you decide you want to use Jupiter, you can do so, or you can use, again, there's no difference. If you have a terminal program on your laptop that you want to use, what I'm going to show you and what you do in a terminal, there's no difference, and you'll be able to do everything exactly the same. Okay, so, and let me. Sorry, CD. Okay. All right, so I'm in the same, I'm in my home directory when I've logged in. All right, so when you log into NERSC, you're on what's called a login node conveniently, and it's literally just like a landing space for everyone to get into the system. And you're gonna see a home directory. It's a very small amount of space. So if you've read the Absolute Beginner's Guide, which I wrote, by the way, so I tend to use that analogy often. The analogy is kind of a house, and the login node and the home directory is like your foyer, if you know what a foyer is. Like, this is a foyer, it's like the entry space, right? So it's just a little bit of space. You can walk in, maybe, just do something if you need to. Like, you're not actually gonna sit down and work, most likely, right? You're not gonna sit in front of the elevator and start doing work, right? So it's just a place for you to get into the system and sort of start interacting with things, okay? The activities that we're doing today, I'm gonna show you how to copy them into a space where you can work on them, okay? I'm not gonna talk too much about the sort of storage space that we're using. We're gonna kind of gloss over that for now because it doesn't super matter. But then on Monday, hopefully, if you come to user training, you're gonna learn more about our different storage options because there's kind of different levels of them, okay? So the home space is just to kind of walk in the door, okay? So now I'm gonna start showing you some commands, and then when then you'll have some independent work time to do the kind of exercise, and I'll put a cheat sheet up there. If you don't catch every single command that I'm typing in right now, there'll be a cheat sheet on the screen for you to look, and then obviously I'll be walking around and I'll help you out as well. But this is one of those things where the way to do it is the way to learn it is to just do it, okay? So you've seen me type something here. Let me make this even a little bigger. It's kind of unpleasant to look at, but just so that it's visible. So I typed in this command ls. This is list. I think it just stands for list. I did find this upstairs. This is Unix in a nutshell. So if there's are any commands or esoteric questions that I can't answer, we can go look in the book, but hopefully we won't need that. So list is a command. This is, again, we're talking to the machine. We're saying list. I'm in a directory. You're always like in a directory in some space. You're not like, there's no like nebulous space. And you can see here, this is a whole bunch of old stuff. I actually tried to clean this up a little bit this morning or something, but it's just, it's kind of just a space where I've run some scripts, some small files, things that I don't really need. Mostly it's actually sim links to other folders that I need access to. And in that beginner's guide, it shows you how to make those things called symlinks. You don't have to worry about that right now, okay? So ls is a good one. If you're ever overwhelmed by the amount of stuff on your screen, you can always type clear. That clears everything, okay? So if you've typed in a bunch of things and you're like, I don't want to see any of this anymore, type in clear. The next big one, the main one, is cd. cd, change directory. And, oh my God, stop, Siri. I didn't even touch my phone. I don't know what happened.
I think CD sounds too much like.
I don't even use that. Oh God, I'll have to throw it out into the play. I'm gonna be saying it often. And so this is the command. I'm gonna say I want to move to another directory. And in this case, you're gonna type exactly, so there's two options here. You can go to the Q&A doc, and if you scroll up here, you'll see the directions right here, CD. And this is our little training directory. It's got the workshop materials in there. If you happen to know how to use Git, you don't have to. You can also take it from my GitHub. I'm not sure how, I tried to keep my GitHub up to date, but it may not be super up to date. So I would actually recommend using these set of instructions here. Okay. You're welcome to work in Scratch, or you can work in CFS. You don't have to worry about what those are. Both of these instructions will work just fine. Okay, so whoops, let me get back to my terminal. All right, CD. Then I'm gonna type in CFS and a slash. Yeah.
That document you just showed, did you share it with us by any chance?
Are you in the Zoom?
No, I'm not.
Okay, can you jump into the Zoom? You should have access to it in the calendar invite, and then you'll get a link there. Yes.
We don't have the variable value for CSF or Scratch.
CFS.
Yes.
Are you on a login node?
I am on login 38. But if I do echo $CSF, it doesn't come back.
CFS. Echo.
CFS.
CFS.
Yes.
All right. Gosh, CFS.
But I don't get it. Okay, let me create.
You don't have to do the echo. You can also just type it in directly. Yeah.
Yeah.
So for me, when I try to CD to that, it says permission.
Okay, so yeah, you're not gonna CD directly to this. Let me finish where we need to go. So you're gonna do CD, CFS, and train one. So this is only gonna work if you registered and you're in Helen, can you add Afton to train one, please?
Will do.
Okay, so if you registered and you gave me your username and I was able to add you, you can. If you aren't, for some reason, if you have a username, on NERSC? No, okay, so you're gonna watch this part, okay? So again, you have to have a username for this, and in the sort of turnaround period of time, we weren't able to get everybody's accounts, right? So if you don't have access, please watch someone who's doing this, okay? You're gonna type in, for the record, you can also just do this on your computer, right? So this whole part right here, you don't have to do on Perlmutter. So here, let me show you one thing. So if you wanna practice some of these things, okay. So this is gonna be ugly, but. Okay, so this is my laptop, right? This is just my laptop, okay? And let's say, we're gonna go, I'm scared to show, I don't know what's where, but let's go into my Dropbox for a second, okay? So my Dropbox is gonna be a disaster, okay? But it's gonna show you all these files, right? So you saw me do CD, right? So this isn't me on Perlmutter, okay? So you can practice some of these things on your laptop with your own files, okay? The point is if you normally on your laptop, you're using your Finder or you're using a Windows Explorer or whatever the Windows equivalent is, you're usually doing drag and drop, things like that. The practice is to now do it in a terminal, okay? So if for some reason you're on Perlmutter right now, try doing this on your laptop.
Yes, it says that, I think it says we've let the host know.
Okay,
So I think
yeah.
it's permission. Thank you.
Okay. Okay, so now we're in, and you can see, and this is fantastic, I can see a bunch of people have done the instructions, which is to make their own copy of the fundamentals training materials, yeah.
I was able to log into ntrain one, and when I do ls, it says permission denied.
You're able to log into ntrain one?
Yeah.
You may have a CD in there?
Yeah, CD.
Okay, so you might be able to CD and look around, but you may not be in the,
Yeah,
see
you can
things.
go to that place, but you can't make any changes unless you are like.
So put your username in the chat for Helen. In the chat, in the Zoom chat, type your username, and Helen's gonna add you to Entrain 1 right now. And ideally, it will let you in the next couple minutes. Sometimes it takes the system a few seconds to update. It may take a little longer, but if she can do it right now.
Yeah, it'll be added to the project, but to run the batch jobs, it may take up to an hour.
Okay. We added everyone to Entrain 1 who had registered. I think I finished adding everyone last night around 8 p.m. So if you registered after that or you didn't register.
We could do the git clone version instead though, right?
Correct. And you could do that into your Scratch.
All right.
You may not be able to run the Slurm scripts because, well, you could. If you have a NERSC account, then you have a default project. And so we'll get to there. If you We'll figure it out. The benefit of being able to get into this project is that I think you all have like 50 hours. So then we can run some Slurm scripts, okay? Okay, so now you've made a copy. And so now I'm gonna show you what your assignment is or your little mission, so to speak. Okay, so first thing we're gonna do, and kind of the narrative here today, is that you are a new student or intern, which maybe some of you are, you're doing a research project. Your collaborator has given you a messy project directory that contains data, files, scripts, notes, all these different things. Your job is to log in, copy the stuff to your workspace, use a terminal to inspect and organize the files, get the scripts running, and learn some troubleshooting, attempt some optimization. So right now, we're gonna start with doing the messy project cleanup, okay? So if you've copied over the materials for the workshop, and I'll go back to that. So I'm gonna go into mine. You'll see here, there is something called messy project. I'm gonna CD. And one thing I'm doing, which hopefully, if you haven't learned already, I highly recommend using, is tab completion. So how many of you know what that means or have used it? Some of you know. Okay, so tab completion is basically when I started typing, so let me go back here. So I started typing CD, and notoriously typing and spelling is hard, so it's easier sometimes to not have to type or spell things too much. In this case, so you'll see, so one thing I'll show you is what I wanted to do is I want to start typing the name of the directory I want to go into, and then I wanted to figure out which one I'm trying to get to. You'll see here, there's actually two that are called, one is called environment and one is called example. If I type E, and then I press tab complete, it actually didn't do anything because it wanted me to kind of like notice for a second that like, this isn't enough information, right? Because there's two different options here. Then sometimes if there's a million different options, it'll ask you if you want to list all of them. Otherwise, it'll list both of them. And it says, hey, you need to pick. I don't know which one of these you want, okay? So in the other case, though, we're very lucky. We don't have more than one of these or more, even something starting with an M. So I can type in CD space and then start typing in messy project. And before I even get to, I could just have left it at the M tab and it completes it for me. And then I can just press enter. So sometimes when you see people like moving real fast in their terminal, you know, and it's just because they're using tab complete for stuff and they like know their directories really well. And it's not because they're some kind of like wizard. I mean, they may also be a wizard, but not necessarily. You'll also see in my prompt, it shows the entire directory path. So if for some reason you were struggling, so the thing that I used, and again, I glossed over this because some of it, it's like, if I tried to explain every single thing, we'd be here for way longer. But it's just kind of like a shortcut that exists on the $ CFS. It's just a way to point to the space called CFS. But you don't have to use that. You can also type in the whole thing, okay? If for some reason your prompt or you change your prompt someday and you don't know where you are, you can type PWD. PWD means print working directory. This is really helpful when you need to tell somebody else where to find something because they're going to want your full directory, your full file path. Okay, so if you have a collaborator and you've put some files somewhere, or in this case, they've said, hey, go copy my files, they probably ideally give you their full working path so you can find it easily, okay? All right. So now I'm in this messy project directory. I feel real called out here because in reality, this is probably what my directories would look like. When I did my scientific research, it was always kind of a hot mess. And so before I gave it to someone else, I would maybe try to clean it up, but that doesn't always happen. So sometimes you inherit a project and it's like a gigantic disaster. Does anyone have any thoughts on why it might be useful or necessary to clean up after yourself?
Not to fill it up the disks.
Okay, so not to fill out the disk. That's probably one of the most important ones, right? Yeah, do you have another?
The project's collaborative, so other people have to deal with your mess.
Exactly. That's a really good one, right? Because everyone, first of all, everyone can see your mess. So, you know, that if that bothers you. But also, if someone else is trying to work with you, it's really hard when everything is kind of a disaster. Yeah, did you have something to add?
Yeah, and I have to deal with my mess afterwards.
Your future self will thank you for cleaning up later. My current self is very mad at my past self for not doing this. So take it from me. It's really nice to clean up after yourself. But one of the really, really important things I mentioned is that we are on a shared system, and CFS is shared in your project. So if we were all working on the same project and, you know, Acton went in there and put like this huge data set, and then she's taking up the space. Like we can't use that space, right? Because all of her million data files are taking up, and she doesn't need any of them. She figured out what she did. She did her analysis. She did her machine learning training. She can move that data somewhere else, and we have places for that. So part of being a good citizen on a shared system is to clean up after yourself, okay? For yourself, for your collaborators, and also because the system has finite space. And there have been times in my lifetime here at NERSC where we have like an end staff sort of space. And every once in a while, it's sort of like, hey, someone's using up all the space. Like, can you move something, right? It doesn't happen super often, but it can. So definitely clean up after yourself. Okay, so now is your chance to practice a little bit of these skills. All right, so we have another 15 minutes actually. So go ahead and practice. So your job is to clean up that messy directory, right? Go in there, explore everything. So again, the point of this is for you to have some reason to try some of these different commands. The ones to be aware of, careful of, are the one that remove things. So if you type in remove and then a file name, it doesn't ask you like, are you sure? Like, gone.
And you cannot get it back.
And you can't get it back. There are situations where you can at NERSC, but let's pretend you can't, okay? For your purposes, you can't get it back, okay? But you shouldn't assume you can get it back, okay? So for the most part, don't assume you can get it back. The other thing here we have is these little dash, and then there's like letter or maybe a couple letters. So those are called flags. And so the dash tells the command, I'm going to tell you something else I need you to do. And then the letter is sort of like what the thing is, okay? So for example, ls minus L, you'll see, you can do it, welcome to do it. It's sort of like a detailed list. And so it'll actually show you all the permissions, it'll show you like dates, it'll show you how big the files are. So it shows it in, bytes, I think actually, maybe. We've done, I don't know, I think it's maybe, it's in bytes. Is it really? Yeah.
Are you sharing those slides after?
Sorry?
Are you sharing those slides?
Oh, these slides? Yeah, I will. Yes. There isn't a huge amount of information in them besides this kind of thing, but you will absolutely have access to these. I'll put, in fact, when you guys are working on this, I'll put the link in the Q&A because it's available to you. So let me do that in a second.
Oh, where did I read?
Actually, Helen, you may be able to, because I think I did set up the permissions correctly to share this presentation in the Q&A. So then the other main one that you need to know here is -R. So what is -R? Anyone used it? Does anyone know what that is?
You could recursively do this.
Recursively. So recursion is a thing that comes up in like computing a lot. I'm not sure where else we see a lot of recursion, but recursive means like there's some function and then it kind of like does itself again and again and again until it gets to like the bottom of the thing and there's no more to do, right? And then it kind of goes all the way back up. So in this case, what that means is, I think I probably had the -R in my instructions, hopefully I did, because what I wanted, not only for you to sort of copy the each directory, but I wanted to tell the computer to copy everything inside of the directories as well. And if those directories had directories, then everything inside those directories, right? So it's directories all the way down, and I want all of it. So if you're moving things, if your CP is copy, you also want it to grab everything else inside. Otherwise, it'll just give you the folder and nothing inside of it. Okay? That said, if you do rm -r and then a directory, it will delete everything. It will delete the directory and everything inside the directory. Okay? So rmdir is great for empty directories. If you've happened to already clean up and then you want to just clean the empty file, you can do that, an empty directory, you can do that. If you know for a fact you want to clean up an entire directory full of things, you can do rm -r, but be careful. Make sure you've double checked that everything in there is stuff that can be deleted, because otherwise you will delete all of it and it will be gone. Okay. An easy way to look at files. So one of the best ways is to use this cat function, and that kind of spits out the contents of the file. So if you just want to quickly look, you don't need to edit it, right? So the point is you're not going to be changing the file, you just want to see what's in it. You can do cat and then the file name and it'll dump it out. If you know that, I don't use less very often. I don't remember exactly what less would print out. Who's used less?
I use more.
Okay. There's also head and there's tail. So head will just print out the first some amount of lines. I don't remember exactly how many. And tail will just print out the end of it, like the end of the file. So if you just need to know, let's say, and we're going to do this later, we're going to run a job and we want to see how long that job took to complete. So we're just going to use tail and then the name of the file, the output file, to see what it says at the bottom, because that's where it's going to have spit out the time it took. Okay, and then the last one, this is part of that good citizenship thing. DU means disk usage, and this is a good way for you to check how big your files are and how much space they're taking up. And so I think in this, the messy project, it's not very big because none of it's real. It's all just made up. But in general, every once in a while, you should double check how much space things are taking up, because each user kind of has a limited amount of space. Okay. All right, so now you have some time to work on this, do some practice, and at the end, if you'd like to share or make some comments on what this process was like, that would be great. Okay, go for it. Yeah.
The idea is just to try to figure out which files you want.
There's no right answer. It's just for you to use some of these, try things, try deleting things, see if there's anything that can be deleted, just to practice these commands. So there's no right answer here. Assuming you don't delete the whole thing and call it a day. But so just practice moving things around, looking at it. Like you would if someone handed you a new project and you need to figure out what have they given you.
Question.
Yeah.
Just so I signed up for the paid, but I think, I'm pretty sure somebody else had the same issue.
What's that?
For the training. I'm trying to access.
So for the training, that email about the training account, does that have your password?
That's a good.
Okay, let me try to see.
I don't know. They
I might have to stop because I need to use this laptop.
Oh,
anyway, so.
Oops. I think email is. Oh, yeah. Not to the picture of it, I'm not sure.
Yeah, I'll take the minutes.
It's not this. I'm just looking.
What was your account name again?
My account number was training for 80.
You didn't take minutes.
480?
Yes.
Okay, so you are not in here for some reason. Okay, let me add you. Okay, so for anyone who, for some reason, isn't able to get into the, and grade, let me show you what you can do. Once I find Zoom.
One nice thing is
So instead, so where we had the instructions, so you would be able to do this. Let me go back.
once a day.
Okay, so one thing you can do, you can type this in, I'm gonna show you right now. So if you, for some reason, aren't allowed to make a directory in here, what you can do is you can do CP, do you need minus R? Yeah. So you're gonna, we're not done yet, don't press enter. So CP,
You don't have a count?
and then put a space, and then a $sign, and then in all caps, type scratch. There we go, scratch. Did I spell it right? No, I didn't. Scratch. And press enter.
Yes.
And then you're going to CD to your scratch space. This is just another space that you own, actually. And if you press LS somewhere in here, in my case, because I have a bunch of other stuff, I also have this RO. And I can go into here. Okay, so for anyone who wasn't able to get into ntrain 1, if you tried to copy it into ntrain 1 and you couldn't, do this instead. So do CP and then a space minus R, and then the name of this directory, which is RO HPC Fundamentals. Leave a space and then type in a $sign and then scratch in all caps.
Well, I think they might not have permission to do that.
Oh, really?
Because I just tried to do it and I still don't have permission. Like I can't access that RO HPC fundamentals.
Okay, so then,
Same
okay.
reason I can't create my own directory in that.
Okay, so then this is our last, okay, so now instead, okay, here. Okay, now instead, go CD, scratch. Okay, new instructions, all right. So make sure you're in this, so slow. Make sure you're in this thing called scratch. The way I did that was I typed in CD and then scratch. Right? Is everyone there? Then you're gonna type in, and you're gonna go to the Q&A doc and type in this, or grab this entire, this line right here. Oh my gosh, I can't highlight this whole thing, okay, so copy. And then you're gonna go to wherever your terminal is. Let's see, is it this one, which one am I here? And you're just gonna put that exactly and press enter. Oh, it's because it doesn't like the fact that I already have it.
Oh, yeah, so. Yeah.
Okay, so ignore this. I'm kind of doing something else. But if you do that and you press enter, it should work. The reason it's not working for me is because I already have it. Does that work? Yeah. So now try doing. So now in your scratch right here, you should be able to do that. And that should have all of it in there as well. So if you're in scratch, do CD and then type in the name of this over here, HPC. You can type HPC and then press tab. And then do an LS.
You can try to do.
Did it work?
This.
Yeah.
It did?
Yeah.
Yay. Okay, so for some reason you weren't able to get into ntrain, use the git clone thing and you don't have to know anything about it, just copy and paste it. And now you should be able to work with it. Okay? Yeah, so I'm gonna put that cheat sheet back up. And try moving things around, try looking at some of the files, try cleaning it up a little bit. And if you're really bored, you can go look at the other stuff too. And that's what we're gonna do next. So after we've gotten the materials, we've practiced a little bit of using the commands in here, we're going to actually start submitting some jobs, okay? For those of you who are not in the N-Train account, you are probably in another project, right? An intern. Or a lot of you in something called an intern, or we can look. I'll come over and look in your thing. We should be able to see. Oh, because you have a training account.
I don't know if that's for with my.
Oh, use that one. Use that one for when we do the next part.
Okay.
Okay. Yeah, I have access. So you'll need to do this again. Into that account, right? Because this is like a separate.
Well, it's before we raised my mentors account, you had already mentioned we had to sign up for the training one to do the training today.
Well, but she said it'll take like.
But the funny thing is, if you. Let me.
Yeah.
Okay, quick note in case, I for some reason thought that there was another CP here. So the CP command, you have to give the directory, like the source directory, and then where it's going, like a destination. So that it's a little hard to see, but there's actually a space and then like destination. If you don't have a specific directory, you can put a dot. So let me show you what that looks like. So get out of my way. Okay, so let's say I wanted to, so I'm going to, first of all, let's say I want to make a directory. So I'm in my little HPC Fundamentals, right? It's very slow. Make dir testing. Okay, so now I've made a directory called testing. And then I want to CP recursive all of the stuff in the messy project into testing. Oh, sorry, CP, not CD. See, this is, let me check things live, mess it up. And now if I go into testing, the messy project stuff is in there. You'll notice that it's sort of like another directory. So if I want to avoid that, what I can do instead is, and I'm not gonna do it here. I don't know what I'll do if I just do it right in the same place, but you could type in, if you're kind of copying something from somewhere else, and then you could put a dot. Dot means here. So this particularly works when you're copying something from somewhere else. So over here, you would have your full path. So, you know, what I could even do is I could copy the one all the way from my CFS space, which I think is here. And then, so this is like a full path, CP minus R. I wanted to copy everything recursively, and then the dot means right here. Okay, so when you're copying something, you have to have a destination for it as well. And that's also a time where you can name it something else. So if you wanted to, you can, I guess you can, I think when you move things, you can rename them. Maybe not when you copy them. When you copy them,
You can just, if you, instead of putting dot, if you put like a name dot slash the name, or yeah, I think that works.
Will that work?
Am I wrong?
Oh, it's just, it doesn't like my path here. All right, hold on, let me fix this. Oh, I know why. I forgot to do ntrain one. Be messy project. Oh, it doesn't, oh, there's two.
So you need a dot before the something else to say that you want it to be here slash, like dot slash something else.
Yeah.
But then I would rename messy project into something else.
Into something else, right, the copy of it.
But yes.
So I think if I do this may work, this may not work.
Yeah.
Hopefully work, like, iterating, yeah.
So it's
Okay,
basically.
which I'm already inside of this, so it's all becoming kind of a disaster, but. So when you use the MV command that was moved, whoops, where'd it go? And the CP command, those are when you can, and so you can see that here, move old name to new name. So that's a way to, but move will it retain old the copy? No.
There's only one copy, you just rename
it. Okay, so move is equivalent to.
So what you did was like copy and then move all in one.
All in one command, yeah. Okay, so we kind of worked a little bit through our break right here, but let's take a break. So make sure you get up and walk around a little bit. Oh, I forgot to mention for those of you we're gonna keep going, just so we can at least get to submitting some jobs and seeing what some of that stuff looks like. So we're gonna keep going here. The next little bit here. Okay, so just as a recap, ideally we've gone through some of these things now. So hopefully you've learned and practiced a couple of basic terminal commands. You've learned how to copy and move around directories. I know it's not easy, and we ran into a bunch of like, again, technical difficulties that had almost entirely to do with like security permissions for who gets access to what, right? And so that's something, again, you have to contend with that because we are a big facility. People are trying to get in and use our GPUs to mine Bitcoin, right? Like there's reasons that we have certain security protocols in place. And so that's why sometimes we have to like run into some of those things. But ideally, if you weren't able to do the like ntrain thing, and you have a NERSC account, then it means that you have access to some compute hours, and I can help you individually figure out what those are, so you can use some of those to try the exercises if for some reason you can't use the ntrain hours. And if you don't know what I'm talking about, don't worry about it, we'll get there, okay? And again, just that fact that shared systems have sort of limitations, they're shared. So it's good to sort of clean up after yourself. Okay, so now we're going to talk about running jobs. We're going to talk about Slurm. So first of all, what is a job? So this is the only part of this is lecture, so apologies. But so job is like a computation, right? It's like I need to run a unit of computation on the system, right? It could be for me when I was doing my PhD, it was like a particle tracking simulation. So I initiated a bunch of particles and then I integrated them through some magnets and then I found out what they look like at the end, right? And so that takes a lot of compute to track, you know, in that case, it was like 1,000 or 2,000 particles. But if you want to do more than that, it takes a lot of compute. So that's what a job may be, right? Some kind of, it could be machine learning training. A lot of people are doing those these days. If you're training like a surrogate model or something, you set it all up and now you want it to just crank out in the background, and then at the end you're going to have your model and you're going to be so excited that it's good. So that could be your computation. So it will vary on what you're doing. The job scheduler or workload manager is what is managing everybody's jobs in a couple different ways. So it's going to allocate resources to you. Resources in this case means like nodes, pretty much, yeah, like number of nodes that you need, which kind of node do you need, and how long do you need them for, right? Because if you can imagine, there are 12,000 people, and even if everyone was running a one node job, all 12,000 people can't run a one node job at the same time because we don't have 12,000 nodes. So there would still have to be some kind of queuing or waiting situation, right? The job script, and we're going to look at some of those, that's one of the ways you can tell the scheduler what you're going to need in order to run your computation. And if for those of you who have access to the scripts or the folder, you'll see something in there called Slurm scripts. You're welcome to go and look in there and see what those look like. That's kind of like the recipe. So again, going back to my house metaphor, in my house metaphor for the beginner guide, the sort of like kitchen is where we're cooking, we're computing. And so the recipe is me sort of like telling the stove, go and cook this for me, and here's the instructions on how to cook it, okay? And then another way we can do it is the interactive job where I'm standing at the stove and I'm actively cooking, like I'm doing the cooking as opposed to letting the sort of system run it for me. So we're gonna talk about both. We're gonna hopefully be able to use both of these today. Okay. So in general, there are many different workload managers. The one that we use here is called Slurm. It's not an acronym. It is actually just a word. So everything that you'll see we have today, like all of our commands, will start with an S, and that not like exclusively, but oftentimes the S is sort of like, it's a Slurm command. It's something you're telling the workload manager to do. And so Slurm is this thing that's running in the background that you will interact with quite a bit, but it's taking care of all this sort of scheduling. The main things it does, like I mentioned, allocating the computing resources. So if you need a node or 2 nodes or 5 nodes or 10 nodes or 1,000 nodes, it takes that into account. It will execute the job, and it will manage what are called priorities. So like I mentioned, because it's a shared system, there are 12,000 nodes. Even if somebody needs 2 or 3 or 5 or 10 nodes, there needs to be some way of keeping track of like, okay, whose turn is it to use the system? And the way that's done is something called priority. We're not going to talk too much about priority today. That we will probably talk a little bit more about in the new user training, but I'm happy to, if you have questions about it or something, happy to answer those. It is a little bit of like there's a little bit of hand waving mystery magic in there. I mean, it's not really, but it's a very complex process. And so don't expect to like understand how priority works. And some people try to like game it, and I'm not sure how much that works. Okay, and then so if you happen to have, please.
Oh, yes. You know what scheduling algorithms you guys use for the Slurm? Is it specifically
one type of or?
Algorithm. I don't know anything about the scheduling algorithms. I mean, do you mean like how priority is calculated? Or
Yeah, yeah, yeah.
Okay,
Sort
so
of like how is that? Yeah.
yeah, so the priority, and you can go into, if you go into our documentation and look in the queues and charges section, and running jobs.
HPC Fundamentals?
No, in the NERSC documentation. So go to docs.nersc.gov. It may have more details about what you're asking about, but.
Thank you.
Yeah.
I appreciate it.
Sure. Yeah, so there are different ways, like Slurm is actually open source, even though I think the company that makes it was recently bought. I think Slurm is still fully open source. And so everyone who sets it up kind of sets it up their own way. So even if you've used it before, it's not like it might be a little bit different. Okay. So this is just a little bit of basics. We've talked about a couple of these things. So first of all, when you connect to Perlmutter, you get into what's called a login node. That's like, remember the foyer, right? This is kind of like where you enter, a lot of our Jupyter you've seen, some of them, oftentimes you can run those on login nodes because the amount of, like, whatever you're doing is very lightweight. It shouldn't be using a huge amount of the system. But they're not meant for computing tasks. So you shouldn't get in there and then launch your, Python, run massive full training, .py or something, right? Because that is not what a login node is for. And most likely we will notice almost immediately and be like, oh, that. And then we'll help you do it the correct way. So at any point, if you do get an email from us, it's usually like, can we help you do this better? Not because you're like in trouble. But yeah, so they're shared by everyone and there are 40 of them. So if you do the math, there's like hundreds and hundreds of people on a given node, right? Given login node. So when you're ready to actually do some kind of computation, it's going to go on what's called a compute node. And those we have, how many? Almost 4,800 of, okay? And so that's part of the reason why we use Slurm, because when we're ready to start doing things now, we need to say, hey, I want to get on one of those compute nodes. And Slurm's like, okay, let me set you up.
So how many CPU nodes?
3,072 CPU nodes.
Do you know the reason of the split?
Of the split?
Yeah, like.
Well, I think it probably has a lot to
Yeah,
do with this sort of history of computing, and GPU acceleration is, newer for a lot of scientific codes in particular. So, for example, Cori, I think, wasn't entirely CPU.
Cori was like the weird.
It had two different types of CPUs and yeah. I started on Cori, so for me, Cori was just Cori. I couldn't have told you it was weird or not, but it was all CPUs, I think. Okay,
If it doesn't have a GPU, it's weird to me, but.
Whoa. Yeah, go for it, yeah.
So like when we're logging in, when we're like doing terminal stuff on Perlmutter, that's on a login node and we're sharing that node with like probably hundreds of other.
Correct. So if you're on a login node right now, if you're in, are you logged in right now? Type in top. And let me do it right now too. Let's see here. Type in top. You can type it in wherever you want, and then on here it's showing me I'm on a login node, and right here it says there's 829 users.
What was the command you said?
Top. T-O-P. Wow. T-O-P. Top.
Oh.
And then to get out of it, you're gonna do, at least on a Mac, it's Control-C. Control-C. That will end it. Okay.
So those are all the users that are using the node.
You can also hit Q, I think.
Yes.
I think it's also Control-C on Windows.
Control-C on Windows, okay. Yeah, you can do top, you can do, yeah, so the users in this case is actually, the different people. There's all these different things. I don't know what.
It's all of the processes
All the
that are
processes.
running. Like you see PID stands for process ID. And then it shows you which user is running that.
Right, so it shows the user and then it shows it actually shows what they're doing.
There you go.
There you go, Grant. Let me see what I got.
I guess those are different folders, maybe of it.
Yeah, I don't know. I feel like if the memory gets really high, it's when they start getting concerned about it, but I don't know, maybe not.
It's just because like there's 382% CPU.
Yeah.
That's, but I'm guessing it's like of more, like so they're using multiple cores. course or something, because how is it that high?
I'm so glad that you were asking that because I sometimes see that too and I'm like, I don't really know what that means. And then I move on.
CP%.
Okay, sorry, we're just pondering what all these numbers mean. Yeah.
So that's probably why like sometimes stuff takes long.
Yes, it is exactly why sometimes things take too long. And that's a very good point. Thanks for bringing that up. This is part of our good citizenship on shared resources. Because if you're on a login node and you're using up a bunch of it, and it would actually be so fun. I mean, this is running a little slow, so it might be actually. It means that someone is maybe doing a little bit too much Python on here. Like sometimes that something really fast is okay, but sometimes it's a little bit much. So if it's fast, maybe whatever, it's not a big deal, and we're not really calling anyone out here. But for the most part, good best practice, requested practice is not to run massive computation on a login node. Yeah.
Is this window is like the top window organized by like memory usage or like, you know?
I think it's organized by the CPU percentage. So if you saw it kind of fluctuating, it was because it was usually like pushing up, and I've paused it now, right? Like I've gotten out of it, so it's not updating anymore. But I think it's usually, and you can see it's roughly like 99, 96, 95, like, so I think that's pretty much.
The three numbers are the average usage of the computer.
Okay.
And if you type 1, you see how many CPUs the computer has. That number needs to be spread through CPUs, and if it is above 1, then we are over 100% used.
Yeah. So anyways, this is kind of a sidetrack, but again, the point is that login nodes are used by tons of people, so when we're ready to actually do something, we don't want to use a login. Okay. So back here. Okay, so let me go back to my slides real fast. Okay. So let's see, what do we have next? Okay, so as I mentioned, there's two different ways of, and we're going to try both of these. The first thing we're going to do is first of all, we're actually going to launch a batch job. I've done something for us which is called a reservation, which means that we have some part. We actually have right now, I think 20 nodes that are just sitting there waiting for us to use them. And so we're going to use them now. And then at the end of this training, so at 12:30, they're going to be relinquished. It's literally Slurm is waiting for us to use them. And I'm going to show you how to use them. And then the reason for that is because otherwise, if you just submit it to the job and we have this quality of service, it's sort of like, how much urgency maybe is there in your computation? How long are you willing to wait? If it's something you're like, I can run this, first of all, it's Friday, gonna launch it. You don't have to worry about this, but we keep track of, you get a certain number of hours. That's like your budget of how much you're allowed to compute on our system. If you don't want to spend very much, you can put it in one of the queues that isn't very urgent, right? It doesn't use up a lot of those hours because it's sort of like, you can run this when you have time, right? It's like the way I do this. It's like, oh, don't do this right now. Like, do it when you have a moment, right? It's very differential. But if it's like, I need to submit this paper in 2 hours, I need this number right now, then you're going to pay. It's like trying to ship something overnight. The other day I was trying to ship something to my aunt overnight and they told me it was going to cost $120 and I was like, never mind. But that's essentially what you'd be doing here. If you're like, I need this number now, you're going to have to pay a little bit more. If not, you can pay a little bit less. And so a batch job is the way that you can in particular pay less because you're just going to say, hey, scheduler, here's what I need. Do it when you have time. I'll get back. I'll see it on Monday. Have a good weekend. Right? So we're going to practice that. Interactive job is like, I'm using this right now. So I need this right now. It's actually not like, I don't want anyone to worry about like, when I say expensive, it's not money or anything, right? It just means that like the schedule is like, there's a little bit more of an urgency and we have a way of allocating resources so you get them kind of right away. But the reason to use that is because maybe you're debugging something. So you need to be able to like do something, run it, run a small version of it, see if it worked real fast, and then you can launch the full version as a batch script type of thing. So interactive is meant for like, I just need to run something real fast. I need to like crunch some numbers real fast and then I'll get out of there and I'll be done. Okay. Any questions? Now we're gonna switch and we're actually gonna do some of these things, okay? All right, so, and we'll see how this works. Again, we might run into some of those issues of the different, and I'll try to, we'll try to work around those. So, okay, so now I'm in my HPC Fundamentals. And it doesn't matter if you're in CFS or in Scratch, you'll see, so here it says I'm in Scratch. I could do the same thing in the CFS thing. You don't need to worry about that. Okay, now I'm going to go into these Slurm scripts. So I did CD Slurm scripts, and you'll see a bunch of them. They're kind of numbered by the order that we're gonna do them in. And so the first one here, and I'm gonna look at what's in there. It says, I'm gonna cat the first 01 batch.slurm. And you can't just launch this right away because we have to change a couple things. And so, yeah, so sorry, good question. Cat is just me looking at everything real fast, okay? Okay. Oh, here we're gonna run into it. So I use an editor that's in the terminal that's called Vim or VI. I mean, I think I don't know how to use. Do you use Emacs? What do you use? Nano?
No, I use Vim.
Okay.
Vim is my IDE because I'm weird. Like, I really don't use anything else.
Okay, so it should be okay. We'll get you through it. But is there anyone use any other text editor? Yeah, cool. Sorry, in the back.
Emacs.
You use Emacs. Okay, so if anyone's using Emacs and you need help, this lovely person over here can help you. You've been volunteered as the expert, the Emacs expert. Anyone? Did you have one that you preferred? Use Nano. Okay, great, excellent. So if you have a Nano question, you're gonna ask this person. So the things that we're talking about right now are different text editors that live in your terminal, right? Because normally, if I want to do text editing, like I could pull up like something like I have something called Sublime Text. It's just like a fancy there's Notepad++ or Notepad or something. It's like a really basic text editor. It's like the most basic version of like Word, right? Like there's no fonts, there's no nothing. There's you know what I mean. And so that's what's going to happen in the terminal. We're going to pull it up in the terminal and then change a couple of these things in here to get our job to run. Okay. So I'm going to do and you can copy exactly what I'm doing. So you can type in Vim, and then you're going to type in the name of the file. I put 01 and then I press tab, and then I'm pressing enter. And now you're in Vim, and Vim, we're not using our cursor, by the way. So as in like this guy, right? We're going to use the arrows to move around. And I wouldn't recommend pressing any buttons quite yet because it'll start doing weird things. So the way you tell Vim that you're ready to like do something or change something or whatever is you have to go into a certain mode. In this case, we have to go into the insert mode. So the first thing you're going to do is you're going to press I. You don't have to press enter, just press I. And at the bottom here now it says insert. And so now if I start typing things, it'll start typing things. Did you notice I just typed a bunch of stuff? Okay. If you are typing things and you're like, crap, I've messed something up and I don't want to save it. I want you to know how to do this so that you can always get back. So the way you're going to do this is you're going to press escape. That gets you out of insert mode. Then you're going to do a colon, shift, so I press shift colon, colon is waiting for me to tell it something. And then I'm going to say Q for quit, and I'm going to put an exclamation mark, which is me telling it, I know that I have something I changed that is not saved. I want you to quit anyways and not save my change, okay? So I've now exited Vim, I told it to quit, and now if I cat, the garbage that I had placed in here is not here because I didn't save it. Okay, now obviously you do want to be able to save what you've done. So let's get back in there and let's do this together. So I've gone into insert mode, and right here you'll see there's an account equals, and I've pressed I to get into insert mode. I've backspace, I've gotten rid of the space, the placeholder. And if you are in the ntrain1 account, you can type in ntrain1 right here. And that is telling it this is the account it's going to charge to. If you're not, but you have a NERSC username, then you are part of another project of some kind. I helped another person find out what that project number is in Iris. So if you know how to use Iris, you should be able to log in there and see what that project number is. If you don't, does anyone need help finding their project number?
I do.
Okay, you're not an N-train, but you have a NERSC account, not a training account. Okay, Afton, do you mind helping real fast? I'm not really sure what your
No,
situation
I
is.
have a training account. I will use this, but
Okay.
I don't know what is my account because I never use it. That's why I'm here.
You don't know what your, okay, well,
Because I am behind the scene. I am in the other side.
yeah, I know, this makes it hard because I'm not behind the scenes. Yeah, right here and then right here.
Okay, so I'm using my training account currently because I think my NERSC account hasn't been set up completely. Do you want me to go ahead and do this or no? Like just keep it?
If you have a training account, like, were you able to get into that CFS?
Yeah, so
training?
I'm
Yeah,
currently
yeah.
using my training account.
Yeah, perfect, yeah, then use N-train one.
Use training one and put my project name over here right now or?
As N-train one.
N-train one.
If you are in the N-train one, if you were able to get into that directory and copy your folder in N-train one, then you can put your account name as N-train one.
Okay.
Then here, actually what we're gonna do is we're gonna get rid of this whole QoS thing. You can leave those little dashes, and in the back there, actually, if someone would like to, Afton, if you want to, there should be a whiteboard marker, or someone else can, someone in the back row if you'd like to. Right in the back there, I wrote reservation equals, and the reservation is called, so let me type in reservation. So that's me saying, I have Slurm kind of waiting for me, space, equal sign, and it's called HPC Fun. HPC Fun.
Does the reservation?
Which one we are?
Okay, one second. Sorry, what? Which one, what?
Reservation? I don't
It's
know.
called HPC Fun.
I don't have the line reservation.
Oh, you have to write it. You have to change it, yeah, you're gonna change out QoS,
QoS too.
and you're gonna type in reservation equals HPC Fun.
For that.
Remove the comments.
And then remove, so some of this is, actually, I guess all of it is through comments, but there was like an extra comment here, so you just wanna get rid, so there's just one of these hashes right here.
Like when you
Okay,
type SSH.
So now it's all like this, okay? So the first part of this is how I'm going to tell, this is the recipe. This is the recipe, okay? So I'm giving it a name. I'm giving it a time. I'm saying I need 5 minutes of compute. Okay, this is hours, minutes, seconds, okay? So the time here goes hours, minutes, seconds. I have one node. I'm asking for one node to run one task
You should be able to log in to Iris.
on,
It's the same.
and I'm going to use, I only need one CPU.
It should be all the same.
Okay.
CPU, yes.
This CPU doesn't refer to, like, okay, so this is very confusing and it's not my doing. This incat actually means the cores. So the CPU consists of a bunch of cores. Our CPUs each have 64 cores, and so I'm using one of those cores. I wanted to charge to this account, so the amount of compute is gonna charge, it's not even gonna charge 5. So the minutes gets sort of scaled by that urgency thing. So when you actually charge it, it's probably gonna be like.
You don't need to, yeah, because you don't need to create it.
You may not even see it, I don't know. Because this, for the record, this computation is gonna take like 7 seconds or something. And all it's going, now, you don't necessarily need to worry about the rest here, but what's happening here is it's just a little bit of,
Yeah, however you do
starting,
that.
running it here, and all it's gonna run is this demo.
Oh, you're using it on your
Python
computer.
scripts. If you go look at it, it's like a for loop with some sleeps or something, yeah.
On my code, it says module load Python. Do I keep it or do you want me to remove it?
Yes, please keep that. So if for some reason yours doesn't say this line right here, we're gonna add it. It's module
Yeah, it'll probably, it's gonna be a
load
while. Like you should request the account, but
Python.
it's gonna be like.
So if yours doesn't have this line for some reason, yeah.
That you should.
So I don't think I got on the training account.
Okay.
So, but I'm pretty sure I've actually did an intern, so.
Okay,
I'm
yeah.
just gonna use that, that should work.
Correct. Yes, that should work. Assuming they gave you some hours, which they should have. So if you have access to an intern, or if you have access to another project, I think Afton may help you, but try and.
Just like an hour ago.
Okay, so now I've changed my script and it is, oh, did you have a question?
Yeah, so here, what is the task specifically? Is it running the Python script?
Yes.
Okay.
Correct, that is the task. and I'm saying I have one
That
task.
should update
Okay, so
basically.
we want to run multiple scripts at the same. We'll get to that.
Yeah, you need to use
Big
the
steps over here, okay? All right, so we're gonna run one instance of Python doing one script. One Python script, okay? All right.
So are you trying to create?
So now to save my changes, don't do the quit thing, right? So do the little, what's this thing, colon? And then do W. And then so you can press enter here, or the cool thing about Vim is you can put a bunch of commands in a line and it kind of does them in order. In this case, what I'm gonna do is I'm gonna put W and then a Q. So this is gonna say, all right, Vim, you're gonna write, W is write, save, write, and then you're gonna quit. Okay, so when I press enter,
That should be project name.
done, and I will show you that it did in fact work. Okay, so it made my changes.
Try the,
I just need a quick help. So currently I'm in insert,
Try
what do I
that,
do to
yeah.
get out of it?
So now press, get the colon, so shift colon,
So shift colon,
and that puts you into, yeah, and then now type,
because it's doing it here.
Yeah.
you press escape,
Oh,
escape, sorry,
escape.
escape, yeah, there we go, yeah,
Oh,
to
okay.
get out of it, so you're good. Yeah,
So colon, WQ, correct?
correct.
What is output equals slurm, there's like dash, all that stuff.
Yeah, so you have to hit.
Oh, did you get that's probably, is it a dot out?
It's on yours too. It's one of the S batch commands.
Oh, here, this is, and you don't even necessarily need to specify this, but this is going to make an output file, and we're gonna use that output file. But it's just telling it, I'm telling it what to name it. So you could change this to be like, my output file dot out. And these are placeholders, so this is like regular expression or something like that, I don't know. And it's going to put, I don't remember what X is.
I don't either. I know Jay's job.
J is the
that's why I
job
was like,
ID, but I don't remember what the X is.
But it's a way to personalize it so I know what it is.
Yeah, well, also it'll change it. If you run this multiple times, it's good to have that job thing because the job number changes, so you won't overwrite the same output file. If you just said output equals output dot out or whatever, every time it would write that same file and it would basically delete your previous output. So it's nice to do that.
Right, so just to repeat for the people online what Afton just said, which is that the reason that this output here, we kind of want to leave it that way. You don't actually have to specify this because I think the default output file is gonna have the job ID as well. Every single job that we run has a unique job ID. And so when you launch your job, the output file will have that ID in there, and it's a unique identifier so that if you run it 12 times, each one will be different. So then you could, and they're all, they're in order. So, it's unlike you would not get, 1, 2, 3, 4, 5 or whatever. And you'll see we're in the like millions, billions or something right now. But the numbers will all be unique and they'll be in order. Yeah.
We did not change any other line besides account and reservation, correct?
No, we didn't change. The only thing, if for some reason yours, and this is why it depends, I think that maybe the GitLab version or the version I put on the CFS when I was testing this, I realized I wanted to have this line here, which is module load Python. So if yours doesn't have this line, all you just want to add that module load Python. Because the default Python is weird. Okay, so now what I'm gonna do is I'm going to tell Slurm run this. And I'm gonna do that by typing sbatch, that's the command. So Slurm batch means like, I don't know why it's called a batch job. So someone tell me, I don't know why it's called that, but that's like submitting to the scheduler. And my Slurm script here is called, what is it called? 01 something? Yeah, batch.slurm. Okay, and I'm gonna press enter. And it said it's submitted, and here's my job ID right here. And what I can do is I can type in, this is a shortcut, this works for everybody, SQS. Press enter, 1 second. And, sorry, this is hard to look at. Does it say, I guess it doesn't show because it's in a reservation. Sometimes it will show. Sometimes it'll show if it's like pending or something, but I think because we're in a reservation, it looks a little bit different. Yes.
So I tried doing it, but it said, no architecture specified cannot estimate job costs.
Okay, one second, let me get to there. What was your question?
Mine was, I got an error, batch jobs, no access denied to request reservation.
Okay, so maybe it's your account. So we're gonna check that in a second. Let me see what yours said.
Yeah, so it says, no architecture specified cannot estimate job costs.
Put a dash capital C CPU, because it didn't specify CPU.
Oh,
CPU architecture.
the constraint is in there. It says constraint CPU, right?
Right. Make sure you have this line.
Just as a fun aside here,
Yeah, I also thought.
this is why it calls batch.
Yeah,
batch of cards.
oh, very cool. Okay, let me see what yours says.
This is, when I was in university, we had to do in punch cards. So that's why it's called a batch. Do you have your batch of cards? Yes, here it is.
What's also kind of cool is you can, instead of color, you can do.
Yeah. So, okay, so, right, because you're not part of it. So that's okay. So what you can do is you can also.
Your entire password and then no space, no enter.
And then instead of doing the reservation.
This is the
line,
computer
type in,
software.
Debug. So change out the reservation.
Is that, was each card a different job?
Each card is one line.
Yeah.
Okay, so
They should do it in a
if
laptop.
you are not in.
That's good, I mean.
Hey folks, can I get your attention real fast? If you're not in N-train, oh, sorry.
Thank you.
If you're not in N-train, you won't have access to this reservation. So instead, what you should do is change this out to QoS equals debug.
Could you repeat that one more time?
So in this line, if you're not in the N-train 1 project, you don't have access to the reservation. So instead, we're gonna try to put it in the debug queue and hope that it'll run pretty fast. It should. You can actually, if you want to make sure it really runs real fast, change this to 1 minute. You don't need 5 minutes. It's just sort of in there. Change it to 1 minute and then change this reservation equals debug. Yeah.
So in the future, when I want to be using this, like for my
Write it somewhere else and copy it in.
computation, how do I know what reservation to use?
So reservations exist for things like this, which is like a training event. But on average, you're not going to be using a reservation. You're going to be using a QoS. And I'm going to show you what that means in a second. Okay, so that's the reason that we're using the reservation for this one specifically is just so that we can make sure to get something to happen before we leave today. But usually you're just not gonna have that line. And instead, you're gonna have this QoS here. And that's called quality of service. And that's what you're gonna tell Slurm, like, how badly do I want this?
I just changed my
Right?
password.
Because essentially what you're doing is you're telling Slurm, hey, go do this computation for me. But it's like, well, I have 50,000 of these. So if you want me to do this soon, or schedule it to happen soon, you need to pay accordingly. And so the QoS is what tells
What's
Slurm
nice is.
how urgent is this for you, okay? In the documentation, it's gonna show you what all those QoSs are. In the new user training on Monday, we're gonna talk about what all those are. For today, it's just like, let's just run one of these because otherwise, if you get to user training on Monday and I start talking about queues, you're like, I don't know what this is today, right? So now that we know, we've sort of talked about it, hopefully when I show you some more queues on Monday, you'll have a better understanding of what that is. But we can talk about it a little bit more today.
I got an error that no architecture specified.
Okay, so make sure you have this constraint equals CPU here. Okay. So press escape and then do your right quit. And then I think I should be able to launch this as well.
Wanted to see.
Okay.
I think that's where. Running, right? I have the CPU.
What's that?
So if.
So
I went ahead and did.
Yeah, so that depends on your.
Right quit?
Yes,
Okay, so you
so,
do cat, so this is showing what it looked like before, so you cat, and then, no, so wait, so.
well, yeah, it depends on your VIMs. I forget what.
So do cat space,
So if you do like.
0, 1, and then tab, and now press enter. You did? Okay, and then by submitting it. So to submit the script, you're gonna type S batch space and then the name of the script.
She told us to use the other one. Because you only have limited.
Yeah, it says wrong.
Yeah, well, actually, you need to go to estimate jobs.
I had the same problem because there was 2 comments on the VI.
Oh, did you remove the comments? Can I see yours?
Yes. There were 2 bounds there.
Oh, you know why? It's because it doesn't like these spaces right here.
Oh,
Can you just get rid of those
I'll go
spaces?
ahead.
Okay, I think, I don't know why these spaces are here. If you have spaces,
Like sets your.
if yours has any spaces right here, it's gonna get.
These are like.
I don't know why those spaces are there.
Sometimes when you're gonna edit, it creates automatic, VI creates it automatic, say, oh, this is a comment line, I will make it sure that is a comment. So it puts a bound and a space there.
These are.
So potentially, if you're seeing this, you want it to look hopefully almost exactly like this. Okay.
But,
And there is submitted report, submit that job and number, but it doesn't tell us that's finished, right? We need to check by the output.
Yeah, it will hopefully finish soonish.
But we can check out by the output file.
Correct. So if the output file is there, it means it's done. If not, then, and so the one that I submitted outside of the reservation, now it's showing this TB right here means pending. So that means that Slurm is waiting to schedule it. So if you use a reservation, it probably completed right away. If you didn't, it may still be pending and you just have to wait a little bit. Yeah.
Now I'm getting a different error, which says,
Oh my God.
I guess you weren't sure, right?
What does
So
it say?
now it says no available.
Oh, wait.
Are you in the N training account? You are in the N training account.
Yeah.
Okay.
I'm using a train 267, so it says. Seven account entry. Batch job. Do you want me to use the HPC fund thing, the reservation right now with?
Yeah, if you have access to it, you should, but you should have hours. I don't know why it's saying you don't. I'll have to check that in. That's gonna take me more of a second to figure out. So can you message Helen? So in the Zoom chat,
Yeah.
there's a person named Helen He. Message her and say, this is my account. Can you check figuring out what they have you want and everything?
So this person
Yep.
them?
So what's your account name?
My account. And let's see what it is. Train 267.
Yeah.
67.
Can you check how many hours?
Train 67?
267.
Okay.
You can message it to her as well.
That system.
Do I do direct message or do I do everyone?
And like.
In direct message or yeah, okay. I can already see you are part of N train but not N train 1. I'm gonna add you.
Okay.
Thank you.
So in my case, I think it may have run. Did anyone else's finish running?
I did have a syntax error here on line 16.
Okay, hold on. So if you're, who's finished running? Who has an out file? Anyone else have an out file? Were you able to run it? Yeah. Okay, so why don't we just look at this out file real fast? Okay, so we're gonna, I think both of mine finished running. Let's see, which one do I wanna look at?
Try adding
Okay.
results there and rerun.
Oh, I guess it already finished.
Oh, yeah, it should be results because there is. That's the name of
Okay,
the.
so it's,
Yeah.
everybody will get them. Probably wrong.
Okay.
Yeah.
So does yours have an error in it? Is your out file?
Yeah, there's something like print result.
Yes. Okay, so the reason, so this is by design, it was meant to fail. I set you up for failure here, because I wanted you to see what it looks like when something fails and it has the error message in the out file, right? So checking your out file is important because it will usually tell you pretty explicitly if something went wrong. If something went right, and we'll do that too, it'll say completed, whatever. If you're calculating some number, the number will be in there. But if something didn't go right, you're going to want to check your out script, right? This is particularly important when you're doing something and you ask it to like create a file, like some kind of data file at the end, and you go to open that data file and it's empty, or you know what I mean? Something like that happened because the result that you asked for, like, you know, or a graph, maybe you asked it, it's a Python script and you asked it to export some graph at the end, some plot at the end, and it didn't do that. The first thing to do is to go look at the out file, okay? Because that will show you the error. Now, the weird thing is, and I thought this would do this, but I don't know why. Usually it shows you, oh, you know what, I think I know what the problem is. Let's try one more thing, okay. So go back to your batch job here. This is gonna work better for those of you in the reservation because it should get done real fast. And what you're gonna do here is, so I changed it back to the, oh, sorry, HPC Fund. And here what I'm gonna do is I'm going to type in, right before the Python, I'm gonna type in srun. So srun is telling Slurm to run the thing. And this is gonna become more important when you start running something that has some kind of parallelization built in, okay? And so that's because when you start doing, and again, we have not talked about any of this. This is all stuff you will learn if you take the supercomputing crash course. But there are different ways of saying, and actually there are some examples of this in the end, which I'm not sure if we'll get to, but you can see it there later. When you start saying, hey, instead of running this one process on one core, now run half of whatever this is on, or take this task and spread it onto 2 cores, right? Or 3 cores, or 4 cores. In that case, you are going to want to have this srun there, because now you're asking Slurm to start using more than just the single core that we asked for, okay? And you're going to see examples of that. So you saw that this worked because we asked for 1 core, and it was like, yeah, I can run 1 core, no problem. But when you're saying, hey, I need you to start using more than 1 core, now Slurm has to be involved to help the messaging and the passing things around and like, you know, coordinating things. Okay, so let's try this. So I'm gonna do right quit. And I'm going to submit this. There was a question.
So the parallelization has to be built in the script that we write, or?
Yes. So that is also one of our learning objectives for the day, and hopefully we'll get there. We'll try really hard to get there. But the parallelization comes from your application. It comes from your Python script. It comes from your C, whatever, executable. I don't do C. You have to have built in the parallelization, except in very specific instances. So let's say, for example, you're doing, okay, I'm going to use my physics example because that's the only one I can really think of. But let's say I have a particle, and in my case, I've worked with electrons. So I have an electron, and I'm going to ask my simulation to see where this electron ends at the end of my accelerator, which is just a bunch of magnets, okay? So it's just gonna move this electron around, blah, 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 and then it's gonna tell me the XY location or whatever of my electron at the end. When I was doing simulations like this, I could just give it a random starting position. I said, randomly initiate a particle in this part of the Cartesian plane, you know, XY, whatever, integrate it out, and then give me the result at the end. Give me the coordinates at the end, right? And now I want you to do this for 1,000 particles. If those particles don't interact with each other, right? In this case, they're electrons, they would, but let's say they don't. I could run all 1,000 of those at the same exact time, right? Because they don't need to talk to each other. So in that case, I don't need to parallelize anything, unless my integration is really complicated. But in this case, let's say it's just adding and multiplying, which is really easy for computers. I mean, it's kind of all they do anyways, but then I could have Slurm do this 1,000 times. Go, right? Then I'm asking Slurm to do that sort of parallelization. That's called embarrassingly parallel. And it's a little bit different because again, the point is that it's not that my application, it's not like the next particle needs to know where the previous particle was, right? So that's the only instance where potentially you don't need to do any parallelization, but you're gonna see here in a second. So if we look, let's look at this example. So the thing it's running, by the way, is in this example folder here. And we're gonna cat demo1.py. This is what it looks like. It's a for loop. It's supposed to look kind of like a machine learning thing, but it's just a for loop and it just does sleep and then it's done, right? So there's nothing special in here. Let me show you the one that is going to have a little bit of parallelization in here. Okay. And actually, if I open this in RIM, it might be colorful. Yeah. So this one, and we're kind of getting ahead of ourselves here a little bit, but this one, let me make it a little bigger. Now, in order to do basically the same thing, but to distribute those sleep functions onto different cores, I now I'm using a thing where in my, again, in my application, I've told it you're going to be doing something where you're going to be spreading things out, right? So for this to work and be faster, I needed to build that into my application, not just in Slurm. Okay? Because in this case, what's happening is I want to run, let's say the instead of a sleep, it's like, I don't know, like a multiplication of two numbers. And then at the end, I need to add the result of all those multiplications back, right? In that case, my script still has to do that add at the end, right? So it's kind of this thing where I'll be like, okay, like let's say in this room, right? And we do this sometimes when we're teaching people about this. Be like, okay, here, each one of you do one multiplication task. And then at the end, bring it back to me. And I'm gonna sit here and I'm gonna add them up, right? That's essentially what's happening here, right? And so when we run these, and I have some scripts to show you how to run these, you'll see that the first time you run it with one core, it'll take 32 seconds. The second time when we use a few more cores, it'll be cut down by that much, and so forth. Right? Okay, so this is batch scripts. This I'm just showing you because I know we're all interested and excited about this. Let's get an interactive session because I really want you to know how to do that as well, okay? Okay, so so now we've done the thing where I told Slurm, okay, hey, go run this for me, right? But there's gonna be a situation where now I want to actively be using one of these compute nodes. And instead of using sbatch, right? So the command we just used so far was sbatch. We're going to use something called salloc, which is Slurm. And then alloc is short for like allocation, okay? And I think I have, let's look in here. I think I have a file that has the commands in there for you.
You've got two different.
Oops, sorry. CD, okay, so let's look at, I think this. Okay. So except here we have to change a couple things too. So you're not going to run this file. It's just for you to see a couple things. Okay, so this is our command here, and I'm using my cursor here, right? I'm going to do, and actually here we can edit this. The nice thing about it being in the text editor is a little easier to edit. So instead of doing this QoS shared here, I'm going to do reservation. And in this case, you're not going to have a equal sign. You're just going to have a space. I think if you do put the equal sign, it will still work, but I don't remember. Somebody can check that. And now I'm saying, okay, so I want Slurm to allocate some resources for me. You're going to charge and train. You're going to give me a CPU, something on the CPU partition. In this case, it happens to be the HPC Fund reservation, but there are specifically these queues that are meant for like real time that are called interactive, I think. And I think I have some examples of what those commands look like in here. I want one node, and I'm gonna be doing kind of the same thing, but instead I don't want, let's see, I think I will leave this for 20 minutes. So now I'm gonna copy. So now I'm using like control copy, right? I am going to write this, okay? And now I'm going to paste what I copied here, and it didn't like something. What did it not like? Oh, you know what? It probably didn't like me copying it. Sometimes it doesn't like that. Oh, it doesn't want the equal sign, I think, right? I think it doesn't like the equal sign. Can someone after you?
I don't, I mean, I would say probably not based on the fact that none of the other ones have the equal sign.
Okay, I think I had two errors there, the equal sign, and I think I had written ntrain instead of ntrain1. Okay, so if you are in the ntrain account, you probably are able to do this, and I can show you, I think I have a really large version of this here for you to look at. So what I've done, and you can, oh, sorry. You don't do 32 here. Let me change this. Leave this 1 right now. Okay?
And remove that equal sign.
And remove this equal sign here. And this one here. And fix this. There we go. Okay. So let me copy this in. I'm gonna actually put this in the Zoom chat as well. Okay, so it's also in Zoom chat. It may, sometimes when you copy paste things from weird places, it doesn't like it because there's like some like weird hidden little things in there. But if not, you can type this in. You can change, you can leave this in here. It doesn't really matter. When you're in the reservation, it's all kind of the same. And so this is going to get us on to one of those compute nodes in real time. So now we can actually sit there, and if you want to be on Python, you want to run your little Python scripts and see it run in, you can do that. You're more than welcome to do that because now you're not on a log. It's not like you're sitting down in the entryway to like, I don't know. What I don't know, whatever anyone like paint a painting or something, right? It's like you wouldn't go and set up right in front of the elevators, right? Like if you're going to paint something, you would go into an office, maybe you would go into the kitchen space where there's like some room to do something. That's sort of the equivalent here. Yeah.
So what's the advantage of using this interactive?
The advantage is it's going to happen right now. So if you're working right now and I need to see how my Python script is running, like I don't want to wait, right? So the reason we don't have to wait right now is because we have this reservation, so it runs right away. But sometimes if you submit something, and because we have 12,000 users, if you submit a job today, it may run tomorrow. So if you need the result, or you want to know if your script even runs, you will find out tomorrow, right? So you don't want to be running what we call production runs. That's like when you know everything is working and it's like, okay, now I can launch these and I can let them go. First, you might want to be doing this to test things, to make sure your script works, right? Because in this case, and I did this on purpose, there's an error, right? So if I launch that and now I'm waiting and tomorrow I see there was an error, and the error in particular is really, instead of results, it's like supposed to be result, right? Because we're humans and we sometimes have typos. You want to make sure your script is running first, maybe in an interactive environment, and then launch your big job with the scheduler.
You know, if you run it in the interactive, also it will take time, right?
Well, it'll take as long as your application takes to run.
Yes.
But that is in addition, that doesn't include the waiting for it to even start, right? So what I'm saying is that like in SBatch, your 5-second script might start tomorrow.
Yes,
right?
you're giving it the scheduler though.
Exactly. And versus this is being like, can you please give me these resources right now so I can run this right now? Yeah.
I'm seeing on my version of this file, it says interactive instead of shared.
Right. So I think you can change Are you able to use the reservation? No. You're not, okay. So I think you can change it from interactive or unshared to, you can either try debug or you can try shared _ interactive. That's the funny thing is that there's a lot of these different queues for different things. So I think you can do shared _, so it would be something like this. And it does this Q, and there's not supposed to be a space there, but it just is automatically doing that QoS. And then I think it's shared underscore interactive. Yeah. And so hopefully that will work. Oh, wow. Double check that works. For the record, the example one, it's called 01 underscore demo.py. That one has an error. Demo 2 doesn't. You're also welcome to go change demo 1 and fix the little. It's just, again, the point was just for you to see what it looks like when there's an error.
Oh, we have allocation done now. I have a note for me myself. When do we drop that?
So however long the time was that you requested, did you put in a time field? This is minutes.
Oh, 10 minutes.
It defaults to minutes.
0:10:0. But it will stay for me for 10 minutes.
And at the end of 10 minutes, it'll kick you out.
Okay, and
So you need longer,
then
you can-
I run SQ again, or an S run?
So now you can, so let me show, I'm gonna show what that looks like now. So now we're in our interactive session, let's see. So now, so one way you can know, so before I was on a login node, so it said L Gupta at login 27. Now I am on node, whatever this number is.
2370.
Right, this is a compute node. Okay, so this is a really good way if you kind of forget what you're doing here. I'm now in my interactive session, and I'm actually on a compute node. So now if I want to launch my big Python calculation, I can do that. Okay, so let me show you now how we're going to do this. So let's see here. Okay, so let's go look at the example real fast. See. You can run any of these, I think, that you want. They're all, besides the first one. The first one will give you that error. So let's run the third one. Okay, so this one, it's still gonna run just fine, even if I don't, like, the parallelization thing isn't really gonna matter. Whoops. So we're gonna run that one. And the way we're gonna do that is you can do it, you don't have to be in a specific place to run it. It's just gonna put your Slurm output file kind of like where you were when you ran the thing. So if I go, so I'm gonna do it here in my Slurm. So you can see I'm in my little Slurm script directory. And what I'm gonna do here is, and actually the instructions are here in this one. So I'm gonna cat. So what you're gonna do, and actually this is missing that module load Python thing. So before you run any of these Python scripts, you just wanna do this module load Python. It's just using a different Python than the one that it defaults to for some reason. And then you can do two different things here. So you can do Python. So you can, or let's see, we can even copy this. Let's copy this right here. So you can do this. This is my like fake machine learning training that's running. And I ran 01, yeah, so it gave me that error right there, right? If I run, let's see if I run, so if I run 2, it should run. We can also do srun, and this should give us an error, which is fine because we're here.
4,162.
Python, I think
instead of a login node.
Example. So dot is, and this was on our cheat sheet, but if you don't remember, that's okay. Dot is like, this path is relative to the previous directory I was in. So you can actually do dot to go all the way back. It just means like up one directory. So I went up one, and then in there is where my examples are, and then I'm going to run 01 demo.py, and I'm using srun, and it should give me some kind of error. I don't really know what it's going to do here, but yes, okay, good. So another reason, and you'll see another Slurm out probably because we submitted 2 of these, or if we didn't, we should. The thing that, and this is part of my like little thing that I really want you to take away from today. Sometimes if you're using srun to run something, right, you will see at the very end, it says srun error, right? And so a lot of people are like, oh, Slurm messed up my really perfect script. Like Slurm has done something wrong, right? But I want you to learn that that is not always the case because the error originated in the Python script. And then Slurm was like, I don't know what to do, right? It just like freaked out and then it said error and then it terminated, okay? So what, and this happens a lot and it's not a big deal, but I'm teaching you now so you're never gonna do this. I get tickets sometimes where people are like, this is broken, please fix it. And I'm like, well, if you scroll up a little bit, you'll notice that your Python script has produced an error and you need to go fix your script, right? This isn't a Slurm issue, it's just your application. If you need help fixing your application, that's fine, I can help you with that. But if you know how to do that, then you don't need me to do it, right? So that's another thing I want you to learn today. Troubleshooting, which you will need to do, should start with checking that Slurm out. And don't just look at the last 2 lines and see the first error and be like, that was the error. Go and find where the error originated, because sometimes your error will originate in some like subfunction, and then it will like cascade through all of your functions. And so you'll see like a bajillion errors, but the first error is the one you have to fix, right? And when you're running something big and it has a big long out file, you'll have to do a little bit of perusing to find the top of that. Like this one, our out file is really small, so it's not really, the out file looks exactly like this. So it's really easy to see it, but sometimes there'll be like so much stuff in there and people will miss it. So just take a second and look at it.
The output comes to a different file?
So this Slurm will basically pipe, it's called piping, all of this. So my Python script, I have a bunch of like print statements and stuff like that. It's gonna pipe that into that slurm.out. So at the end, if I'm not in an interactive allocation, I'm running a job, I submitted my job, I come back the next day, like what happened to that job? I'm gonna go look in my slurm.out and it's gonna show if I had print statements and whatever, everything is in there, right? So use those out files.
Even when we are in an interactive shell, if I run srun Python 3, should create a different file output. Right?
Actually, no, the srun itself won't create an output because it's just like, you're just like running a single command. That slurm.out, it comes from like the batch script. So if you submit it via batch, there will be an out file. Or there's no out file for like the salloc.
I don't see slurm.out after I run.
Okay. Well, if you don't see one yet, it might be because your job hasn't run yet. If you submitted an SBatch run.
No, I am interactive.
Right, so there's not going to be an out.
Oh.
The out comes from SBatch, right? So when you submit the SBatch job, it does everything and then it saves the output. Because it's sort of like, because you kind of told it, it's like, you know, you're in the kitchen, you press the microwave, go microwave, and then you leave. And then the slurm.out is you coming back to your food being hot. If you come back and your food is cold, your slurm.out would be like, there was an error and you didn't press the buttons or you didn't use the microwave correctly, right? So that's sort of the equivalent. Versus when you're standing there and you're using the microwave, there's no out because like you're looking at it. You're like,
yeah, it will print the output like directly.
The output is printed on the terminal.
Correct. When you're in allocation, when you're in the allocation, correct. That's exactly correct. Yeah.
Just more of a security question. Like, so I noticed you're using Jupyter.NERSC.gov's terminal. Is it okay if we use our own personal terminal?
Yeah. In fact, most people do. I'm sort of like a little alien, maybe. No, that's true. People use Jupyter. People love Jupyter. The reason is if you're like, for me, a lot of what I did was like interactive notebooks. If you've ever used Jupyter, they're called Jupyter notebooks or Python notebooks. I can show you what that looks like later. That's not part of today. But it's like a nice interface. But this also has like, it has a bunch of, so I'm not showing you, but there's actually like a file browser over here. Oh, wow. And I can use my file browser. I can like click around and find things, right? So I've hid this from you because that's not what we're doing today. But that's part of the reason I like Jupyter. Sometimes I get to use the like, and I don't have to type in all the commands, right? But some people prefer, it's your preference. And you're, well, a lot of people like using, it's IDE, what does IDE mean?
Integrated development environment. I think.
Integrated development environment, right?
I'm pretty sure.
Something like that. And it's called VS Code. That's a really common one. We get a lot of people asking to use VS Code. And that's, again, it's like, it's got like nice editors and you can like customize things and you can like, it's got like Copilot and all the AI things and whatever, you can like kind of wire it all in through there. You can use that. In fact, I made a video, it's on our YouTube, of how to set up your VS Code. So if you want, you can use whatever you want. There's no security issue. If you were doing something that was creating some kind of security issue, it will be caught before you won't be able to SSH it. It'll be like, no, I don't know what you're doing, don't do that.
Just also side question, so does the Jupyter.NERSC allow you to integrate AI into their system, or is it something that you would prefer?
I don't think you can do it in Jupyter yet. There are some instructions on how you can start doing this. I don't personally do it. I don't really do any of that stuff, but there is a way to do it and you can do it.
We can use our own personal computer and integrate that through there and then start working on it, or that is allowed.
Somehow, I don't know how to do that. There is a way to do it. But you should follow the instructions, and there are instructions online. We also did in April, if you go to our YouTube archive, in April, we had a session on vibe coding. So if you want to see that, it was a little fast paced. It was like an hour and it was pretty fast paced, but you might be able to find some information there. And if you want access, like if the links or something aren't working, then just let me know and I can send you the links.
And the links are on the document, correct? The one that you shared, or?
Yeah, so everything that I want you to have access to for this should be in that Q&A document.
Thank you, appreciate it.
Yes. Okay, so we've seen a couple things. We've run a couple. How has it been using salloc for people? Did you get it to work at all? You did, and you ran your Python script and it worked. Yes. Okay, and how long did it take to complete? To say? Let's see. Mine says here when I ran it, it said 5 seconds. Let me try running this other one.
Yeah,
So try running.
Actually,
It doesn't.
say runtime.
Which one did you run?
I ran the demo 01_demo.py.
Okay, so that's the broken one. Is that right?
But I fixed it.
You fixed it. Okay.
Yeah.
So that's weird that it's whatever. Try running 2 or 3,
Okay.
and it should. So right now I'm running number 3. And it's doing 32, it's doing a sleep for 1 second and it's doing it 32 times. So if my math is correct, it should take 32 seconds to run this. Right? We're gonna transition into briefly talking about how to make things go a little faster here, okay? Okay, great. So look that it took 32 things and it took 32 seconds to do it. Okay. Now, if I want to run this a little bit fast, actually, I think what we'll have to do is I'm gonna relinquish my salloc because we have only gotten 1 core. If you get back to your salloc state, and I'll give us time to do this. Go in here and type in 32. So all I'm saying now is on the node that, and it may have given me more, I don't know. It may have given me more than that. I don't know. Sometimes if there's no one else there, it's just like, here you go. But now I'm saying on this node in the CPU that I'm on, give me access to 32 cores. There are 64 cores, physical cores. And now I'm asking for 32 of them. Should be a clue as to what we're doing here, right? Because remember, our thing took 32 seconds. All right, let's see if it will give me this. And there are Slurm scripts, the batch scripts to do the same thing are in those folders as well. The Slurm scripts, there should be like a 4, a 5, and a 6. They should do the same thing, but in the batch version. So instead of doing the salloc, and we're gonna do it live, if you wanted to submit all of those as batch number 4, as batch number 5, as batch number 6, you should see the time getting slower as well. Okay, so now let's do, actually, is this gonna work? Let's see. Oops. So now let's try srun example, and we're gonna run number 3. And actually, yeah, let's see. Oh, it didn't like, what did it not like?
I think you forgot Python.
Yes, I did forget Python, thank you. Oh, you know what, I also forgot another thing. Because I left my SLOC, I have to do the module load thing again. So make sure you've done your, if you're using a new SLOC, make sure you do your module load Python, then you're gonna do srun Python. And then same thing.
Yeah, dang. Cool.
Okay.
Yeah, you can also email the not.
Okay, so see what it's saying here? It's saying running 32 independent tasks
No, I mean, can you type it into here?
using 32
Oh, yeah,
worker
yeah.
processes, right? So because I asked for those 32 cores, and I said I have one task and I want you to put, I want that one task to have access to 32 cores because my application knows how to talk to those cores and srun knows how to send that information to the cores. It's able to do that, and it ran each of those sleeps on a single core and then came back. We can make it slower if we want to. We can do, I think if I tell it right here. So in my srun, I'm gonna change this to 2 dashes and then CPUs per task, and let's make it 8. Oops. 8. Okay, so all I've done is in my srun, before I hadn't specified anything. Now I'm gonna say, actually just use 8 of those cores. If I'm right, which hopefully, this should now take 4 times as long, I think. Oh, what did it not like? Oh, did I not type Python again? Because, no, I did. That's what did it not like? Oh, okay. So it's not, I can't, I don't think I can do my, why can't I do my srun this way? What am I doing wrong? Oh, it's because I typed it after Python. Yeah. So now, sorry, my bad. Okay, sorry. So this flag in the CPUs per task thing needs to come right after the srun because it's an instruction for srun. And then I have Python and the thing I'm going to run. Now, hopefully this will work. "32 independent tasks using 8 worker processes, and it took 4 times as long." Okay, yeah.
So under what circumstances would we want to like tweak with these settings? Like if it's taking really long, we just like up the CPUs that we.
So if your program can use it, right? So if you're developing your own, you have to build it in to be able to take advantage of more cores, right? Because if I just write my Python script the way I had in that first demo, it doesn't know how to take advantage. So if I could ask for 1 million cores and it's not going to do anything because it still only knows how to use 1 core. So depending on what you're doing this summer, if you have an application, let's say you're working with, there's a lot of common applications that people use on our system. Anyone using something called VASP this summer? Maybe, let's see, what else could you be doing? Berkeley GW. This is like a cosmology. How about you guys tell me? What are you guys doing? Tell me what you're gonna be doing this summer. Anyone got an application or some kind of script? Are you gonna be developing your own scripts? Who's writing their own scripts? Who doing here this summer? Somebody tell me something.
I'm like editing a script that's already made, so I'm just like improving it.
Okay, and what are you improving it for?
Just to make it like there's a current use, and I'm just making it a bit better.
So like adding features to it?
Yeah,
okay.
adding stuff.
So potentially in the adding of features, let's say the feature is something that now takes a long time. It's something that clearly the users of it want, but it's taking a long time. So what you could do is figure out how there's a lot, like, what's the application written in? Python. So there are plenty of Python parallelization tools. One of the ones you saw here is this called multiprocessing. There's also MPI for Pi. Again, these are things you can learn. You're not going to learn MPI for Pi in the supercomputing crash course. But that's another one of these libraries that lets you do parallelization. There's something called Dask. There's all these different things that you can do. And maybe you would want to include that in your new feature to be like, and also you can run it 12 times faster, right? That would be an application. So normally what people are doing, depending on, what kind of computation you're doing, sometimes it's so big that it wouldn't run in a day or two. Like you need it to go faster because you need it to use more of the system at the same time, because you do have a time limit, by the way. You can't have a job that runs for more than 2 days. So some people sometimes will be like, I need one node for 48 hours. And that's fine, you can do that, but you're gonna be spending a lot of your time, right? Because again, your budget on NERSC is like a number of hours that you get access to for computing. So you're going to be spending a significant chunk of your compute time doing that. If it's something that can be parallelized, maybe you'll want to do that so that you aren't spending as much of your time. You can get that results faster because again, if instead of my thing taking 32 seconds, it took 4 seconds. Now, this is a simple example, right? That's kind of what it's meant to be. It's not meant to be like, I could wait 32 seconds, that's not a big deal. But when it's 2 days, I might be like, how can I make this 6 hours, 8 hours, something like that.
In terms of the resource allocation budget, it goes on computation time, not resources necessarily.
It takes into account the resources. So if you were using one node, one core for 48 hours, that's not that expensive. Because if you go look, and why don't I pull it up right here? I'll show you guys.
That's on the docs.
It is in the docs, and it's got all these running jobs, using charges. Okay, so it's a thing, it's called charge factor, and that's sort of calculated based on, let's see here, right? So you use this amount, you used 35 minutes on 3 GPU nodes, right? 3 GPU nodes. And by the way, it doesn't know how much of that node you use, by the way. So sometimes, depending on how much time you have, there may be, again, it really depends on what you're doing. A lot of people who are developing applications for doing really good, like let's say you're doing climate research or something like that, and you have these huge models that you're iterating through time. You will probably want to make it go faster and be able to use all of those nodes because you might be allocated all those nodes and you're paying for all of it, right? So maybe you want to find a way to parallelize across all the GPUs so you can actually take advantage of the 3 times 4 GPUs. Because you're going to be charged this amount of time. And that budget allocation that you have is going to be deducted. 1.75 hours is going to be deducted from that. So I think there is, for example, and we do this because, again, we don't always want you to have to go and parallelize your code. So sometimes you can. There are ways where, depending on the queue, so you have to use the shared QoS here. And now it knows, okay, well, you didn't use all the GPUs, so I'm only going to charge you for the ones you did use.
Okay, so if we over allocate, there's some like grace.
Yes. But also you want to try your best to get the exact resources that you need.
Yeah.
Also, what's another reason why you want to try to be as accurate as possible when you're asking for resources?
You're sharing.
Sharing them, yeah, that's true. But what else? What's
You don't want to ask for more than what you need.
Because it will affect the amount of time you wait for those resources. Because if I need one node, one core for 10 seconds, and I ask for 3 nodes for 10 minutes, the scheduler thinks I need all that time because it doesn't know what my application is and it doesn't know that it's going to run in 10 seconds. So it's like, I need to find a chunk of time in my calendar for you to have 3 nodes for 10 minutes. And you might have to wait. Versus sometimes when you have a job that's 1 node for a minute, it's like, oh, we can squeeze you in. Like literally, that's what it's, there's something called a backfill scheduler, and it kind of goes like, hey, we have some resources that aren't being used right now. I can get you in right here. So that's how sometimes small jobs are able to get through real fast because they kind of get backfilled.
Yeah, how do you decide the resources that you need? Based on your application, of course, but how do you decide like number of GPUs, number of CPUs and stuff like that?
Well, if you can use them, right? Like if your application can't take advantage of 4 GPUs, then you shouldn't, or I guess if you need a whole node, you need a whole node. But if you can't take advantage of 8 GPUs, then you shouldn't be asking for 8 GPUs, right? So it depends entirely on the script or the application. And is it able to use the resources? And that comes from, so for example, you saw in here, I had, let's see, where is it? It's probably not in here right now. But my script had this library used called multiprocessing, and it knew how to distribute the work over different cores. If your application isn't set up to do that, it can't make use of those resources. So you have to know your application. So the person you're working with, if you're here working with someone and they're like, who run these simulations? You should ask them, like, how best should I run these? Is there a way to make it faster? Like, they probably know. Sometimes there's documentation online. Our documentation is very, very extensive. And you can see in here, we have supported applications. Where is it? Using applications and frameworks, we have supported applications. So for example, if you're running any of these things here, you might want to go look at them. And let's see, one of the ones I mentioned was this Berkeley. I don't know anything about this, by the way, so I'm gonna look real dumb here, but in here, it will say like, hey, look, it can do these things. Like, this is how you should run it, right? And it will have some information for you. And sometimes if you're really struggling, so first of all, ideally, if you're here for the summer, you have a mentor who's gonna help you. And if they don't, come talk to me, I'll help you. And then otherwise, there's gonna be documentation online or something, or you can come see this and get an example script if there is one, or if not, you can submit a ticket and try to get us to help you, and we will. We'll try our best to help you out, right? Because we do want people to be able to use the system and do whatever they're trying to do. So if you're really struggling and you're not able to get the help you need from your mentor or someone else, then you can ask us to help you. We'll try our best. Okay, so we are at the end here. I just want to wrap up. And thank you for bearing through all of the technical difficulties. This is what happens when you're doing things live. Everything goes wrong. Okay, so ideally let me go right to the end here. Okay, so for the record, and again, you're gonna have access to all these. But you can try these by yourself. You can try all these here. You also have the Slurm scripts that, and again, you're gonna have these. Don't worry, you got these. So try these out for yourself. Okay. Before you leave, please do the post survey. And also, what I wanted to make sure is that we got through all this. I think we got through most of this. So ideally, and I know some of it might be very confusing still. Don't worry, it's gonna take, I bet tomorrow morning when you wake up and you've slept on it, some of it, this will make sense. And then the next morning it'll make sense. And the next morning it'll make sense.
In the middle of the night, history.
Oh yeah, history's a good command.
Copy your history of everything.
Yeah, that's not a bad idea, actually. Yeah, that'll keep track of everything we did today. This is also gonna be recorded. It's gonna be a disaster to watch back, but if you really need to, you could. And before you leave, please, I need to change one thing. Wait, so don't do, if you haven't done, sorry. I need to change one quick thing in the survey because there's like a secret section. Yeah, 1 second, hold on. Okay, so you're gonna do the same link that you had before. So this survey link here, let me share it again. Right here. And now it's the same questions, and I'm kind of just gauging like, in this session, did I do okay in teaching you the things that we tried to do? It's fine if I didn't, please be honest. And at the end, there's some feedback for me for how to improve things. I'm sure the like confusion of accounts is gonna be in there, totally fine. That feedback is gonna be really valuable for me when I do this again next year and again next year to improve it. So before you leave the Zoom, before you leave this room, please take a second to go back and do that post survey for me. And that's just gonna let me know kind of how I did and how to do better in the future. Okay? You're gonna have access to all these resources. You're gonna have access to the slides. You're gonna have access to me. I work here. You can email me. You can Slack me. No problem whatsoever. I'll shut up for a second so you can do this survey.
the video that you recorded, do you know where this is going to be?
It's gonna be on our YouTube,
On YouTube, okay.
on the NERSC YouTube, so there's a link right here, see it says NERSC YouTube right here.
Oh, okay, so it's gonna be.
So it's gonna show up there, it's not gonna show up immediately, it's gonna take a bit because we're gonna edit, I'm gonna try to make it less of a mess, and we also do professional captioning so that it's actually accessible, and that takes a little bit of time. So just wait, and then you'll see it there, but you'll see some other videos there as well, and you always will check those out, so. And I'll email everybody when that's out, but it may be a little bit, but hopefully you have all the other resources that will help you out.
Thank you. And you said you have a tutorial on, there are a lot of other tutorials based on like how to use the system and stuff.
Yeah, so all of our, we've got tons of, like basically any of these training events that we do, we record them and we put them up there. So, you know, they may, hopefully will be helpful to you. There's some videos that we've been making about like how to do certain specific things, like kind of like the how to log in video or things like that. So you're welcome to go watch those.
Perfect.
There's a lot of other centers out there who do really amazing content. 100% use whatever is gonna help you, because in the end, it's about getting you on the system, getting it to work. The only thing is if you go, like, different systems are different, so if you're going and watching a Slurm tutorial for another facility, they may have slightly different queues, the QoS, the quality of service, is based on the facility, so, you know, you can't necessarily do exactly what they're doing, but you know, if it's a good tutorial for you, definitely use that. Before we all go, please thank Afton for being here last minute, being a huge super duper help for me. Thank you. And Helen was online. I know Helen was here. We had Rebecca, I think maybe. We had Charles. We had Lisa. Thank you to all of you as well. And thank you all for coming on a Friday at 9 a.m. Even if you didn't come at 9 a.m. Thanks. Good job. And I'm going to stick around for a little bit. So if you want to keep asking questions, feel free. All right. Libby. Yeah.
Thanks for the.
Of course. Thanks for being here. Thanks for putting up with all the million. That's the fun part about live computational stuff, right? It's always going to be tricky.
Seems like there's a lot to go through in a very short amount of time too.
What's that?
There seems like there's a lot to go through, you know, very short amount of time too.
Yeah, I know. I think, yeah, that's good. I think next time we'll do this, we'll do a little bit less material. It's more, I mean, I guess there's a trade-off. We can either do less material in the same amount of time or do this material in more time. What do you think?
Right.
If it was longer, would you stay? Like if we had to go past lunch, would you come back?
If it was like an hour more, I think I'd come still.
I
If
wonder
it was like
what if
more
we
than
did
that,
like
it'd
a
be
10 to like 2 situation? So there was like 2 hours before lunch and 2 hours after lunch.
I think that'd be awesome, actually.
Oh,
Yeah.
would you guys do that? Well, I guess it
I would
depends. Would
love
the people next year do that? I don't know, but maybe. Okay. That's good to know. Last time we did this, we did try this once before. I'm gonna mute myself because, oh, actually I shouldn't stop. I can stop recording.